Okay, right. So, hi everybody. I'm Matt. I'm a data scientist at Spotify. I'm the podcast insights lead. Basically, what that means is I have spent an awful lot of time, and in fact, continue to spend a lot of time just banging my head repeatedly against podcast data and hoping that something interesting comes out. I don't build podcast recommendation systems, but I'm hoping that some of the data that I've looked at will help those who do build podcast recommendation systems build something cool. So a little bit of background just to get started. This monstrosity is an example podcast RSS feed. So this is how the creator tells us where to download the podcast, what it's called, how long it is, how many episodes there are, all of that kind of essential stuff. But they also tell us a bunch of less essential but still useful stuff, like the type of the podcast, the season number, the category of the podcast. So, as I say, don't build recommendation systems, but I imagine if you do, you might be thinking, aha, these sound like the sort of thing that I could use for recommendations. So I thought I'd have a look. Are they the sort of things that you should be using? So firstly, I'm going to talk about the iTunes type. I call that the consumption order because that's what it's there for. It's there to tell you in what order should the episodes of this podcast be consumed. Your options are episodic, which is from newest to oldest. So think the news, like you don't start with the first ever episode of the news and work your way through to the series finale in 2020. Equally, serial is the opposite of that. That is oldest to newest, where you do start with the oldest episode and work your way through to the newest. So before I move on, I don't really have any way of testing whether or not you're giving the right answer or not. But if you just have a think, which of these is going to be most prevalent in the podcast world? There are 1.6 million podcasts, or however many it was. Which of these do you think is going to be most common? Just to test your intuition. And yeah, I'm going to have to trust your answers. You're going to have to be true to yourselves and not change it when you see the answer. So 97.5% of all podcast shows are listed as episodic. It's really heavily weighted towards serial. A little bit of information that goes along with this is that episodic is the default for most podcast creation tools. And so if you don't pay much attention, that's probably what you're going to end up with. Why is this relevant for recommendations? Well, there's a couple of ways you could think about it. So at a very basic level, you could say, hey, look, people who like serial podcasts probably would like other serial podcasts, and therefore I'm going to recommend them those. At a more complex level, you could start to think about, okay, I'm going to recommend this user a new episode from a show that they've never listened to before. So what episode should I recommend them? Should it be the most recent or the oldest? And then even for recommendations within existing shows. So let's say I've listened to episodes 1, 2, and 3 of a podcast. Should I recommend episode 4? Well, if it's a serial podcast, probably. Should I recommend episode 304? Well, if it's an episodic podcast and that's the most recent one, probably. Okay, so that all sounds great. But unfortunately, as I said, the title of this presentation should have been Problems, Problems, Problems. Life is not that simple. This is a very popular podcast going through the American Office season by season, episode by episode. It's almost the exact example I gave of a serial podcast, except it's listed as an episodic podcast. So if you were recommending this to a new user and you were going off of the tag, you would recommend season 3, episode 10 as the first episode or something like that. Conversely, this is Malcolm Gladwell's podcast, Revisionist History, very popular. By and large, the best way to approach this, I'd suggest, is you pick a topic of history that interests you and you start with that episode. Yet this is listed as serial, so if you're following, the letter of the law, you should recommend episode 1, season 1, and then episode 2, then episode 3, and you don't do any of the fancy cool topic modeling stuff, you just follow that path. So, that's a couple of podcasts. Is there a way that we could use this kind of stuff to basically infer what is the right way of ordering these? And so one way of doing this is shown in this sort of complicated graph. Not that complicated, could be more complicated graph. where basically we looked at when we introduce a user to a new show, do they listen to one of the first couple of episodes, one of the last couple of episodes, or something else entirely? And things are kind of annoyingly inconclusive. So if you look at episodic podcasts, users are more likely to listen to the most recent episodes rather than the oldest episodes, which is good. And if you look at serial podcasts, the converse is true. They're more likely to listen to old episodes rather than new episodes. But it's not that conclusive. So still, a quarter of episodic podcast introductions, people start by listening at the oldest episode, and a quarter of serial podcast, people start by listening at the newest episode. And even more worrying, you've got about 40% of user connections that are happening just on random episodes in the middle. So I guess I'm not saying that these labels, you should just ignore them entirely. I'm not saying that they're perfect. I'm saying something kind of annoying and in the middle. Maybe you can use them, but if you are going to use them, probably best proceed with caution. Okay. Whew, that was a slog. That was a difficult one. Seasons are easier. We understand seasons. We've watched TV. It's a collection of episodes. You start with season 1, episode 1. Off you go through. So on Spotify, about a quarter of all the podcast catalogue has more than one season. So not loads, but it's probably worth using. Again, you can imagine setting a rule where you say, we do not recommend to a new user season 4, episode 4. That's a bad recommendation. Maybe at a stretch, we could recommend season 4, episode 1. And we could definitely recommend season 1, episode 1. But yeah, that's definitely a use case for seasons. As always, life not being that simple. This is a very popular podcast. It's TM Soft's White Noise Sleep Sounds. Now, there are a bunch of arty podcasts who sort of have these confusing abstract names that don't really tell you what you're listening to. This is not one of those podcasts. This is absolutely White Noise Sleep Sounds. And I would defy anybody to identify where season 1 finishes and season 2 starts of White Noise Sleep Sounds. And yet, this podcast is listed as being seasonal. Conversely, it's Office Ladies again. As I mentioned before, episode by episode, season by season. If anything was going to have a seasonal tag, you would have thought that Office Ladies would have been the one. But I'm afraid it doesn't. And this is That Peter Crouch podcast. This is actually going to be one of my top 3 podcasts that we were asked to think of. I do very much like it. Oh, it was a secret, my bad. But one of the episodes is called Season 4 Announcement. It's definitely seasonal, but it's, again, not listed as being seasonal. So again, what I'm kind of saying here is that seasonality can be important for a recommender system. It could be useful, but you can't just use the seasons tag in order to infer what season a podcast is in and whether it is seasonal. You can look at the episode title, episode description. If you've got the transcript, sure, look at those. If you want, you can look at the episode release cadence and then look for gaps and use signal processing. Like, there's all kinds of cool things that you can do. But what you probably shouldn't do is just use the season tag that's there. Okay, well, this is one kind of fundamental base assumption and axiom of podcasts, is that one podcast show is one RSS feed. You create an RSS feed to contain your show. And naturally, I'm going to say that, well, maybe that's true. So this is a very popular podcast, My Favorite Murder. My challenge to you, how many different types of episodes do you see here? You have got the title, you've got the description, I've given you when it's released, and I've given you how long it is. So the question then, how many different types of episode are there? Again, contest what your answer is. But what I'll tell you is, unless you said it depends, you're probably wrong. Because it does. It depends. So maybe it's one. I said, like, axiomatically, basically, look, it says My Favorite Murder at the top. What are you talking about? They're all episodes of My Favorite Murder. Stop complicating things. Then, yeah, okay, fair enough. I am prone to doing that. But maybe it's 2. If you look at this bottom episode here, this is called My Favourite Murder Presents Bananas, episode 1. Now, this is what's called a feed drop, whereby a podcast effectively shares another podcast by including one of the episodes in the podcast feed. Now, you can imagine how weird of a recommendation that would be if you say, I'm going to recommend you an episode of My Favourite Murder, and you recommend them this episode, which is not an episode of My Favourite Murder. So also, if you're trying to infer user behaviour on My Favourite Murder by looking at how a user behaves on that episode, well, that's going to confuse things quite a lot, because it's fair to assume that they'll probably not behave on that as they ordinarily would on an episode of My Favourite Murder. So yeah, maybe if you gave the answer 2, you were right. But also maybe not, because it's possibly 3 episodes. I think these ones are quite easy to pick out, but you've got the feed drop, you've got the normal episode, and then you've got the mini-sode. So this is released every week, kind of like on the offbeat of the main episode. It's only about half an hour long. The main episodes are about 2 hours long. So now you could argue that this is a better episode to recommend than the main episode, so to speak. But at the very least, you could say, hang on, it might be worth thinking about, are there users who only listen to the minisodes? Maybe these should be the ones that we recommend rather than the main episode. So maybe there are 3. But equally, maybe there are 4. There's a live episode in there. It's a different length to the main episodes, and it's entirely plausible that we would want to treat live episodes differently to the main episodes. So depending on your viewpoint, maybe we've got 4 different sub-shows within this one show, which is My Favourite Murder. Now, is that a common problem, or am I just kicking up a fuss about My Favourite Murder? Well, unfortunately, it's kind of a common problem. So Nerdcast, also a very popular podcast. How many different episode types do you count here? I see Nerd Tech, Nerdcast, Nerdcash, and Speak English. They look like at least 4 different episode types in there for me. This isn't an edge case thing. This isn't 1 or 2 shows. This is quite common. And I'm actually very mindful now of the bias in recommendation systems keynote earlier on. This effect isn't uniformly distributed throughout the podcast catalogue. This is much more prevalent in the more popular podcasts. So as you gain popularity, you're more likely to be involved in feed drops, in introducing additional segments and that kind of thing. So I'm not presenting the solution to this, but I am presenting it as something worth thinking about. Maybe a show isn't a good unit and there are actually sub-shows beneath shows that it might be worth considering. I should have really had a summary slide rather than just this slide, but I think my summary would be, point number 1, I've only talked and I've only dealt in shows that aren't exclusive to Spotify. So just say this isn't a Spotify problem, this isn't like the entire podcast category and catalog problem. And number 2, like you might think that, okay, yeah, all these metadata problems, they might be a problem for the smaller, less popular podcasts, but for the bigger podcasts, that kind of thing will be ironed out. And that's the reason why all of the examples that I've used are big, popular podcasts. I'm saying that this isn't just a small niche problem. This is a problem that pervades basically all of the podcasts across the entire podcast catalogue. And with that, I think I'm going to finish and say, are there any questions, or should we just do some awkward silence?
I have a question.
Cool.
Do you think? Hi, this is Thomas Alderwall. Do you think it's on purpose that the metadata is bad, or is it just ignorance?
I don't think it's on purpose. I think it's more likely that when the podcast was set up, it just either the people didn't know what the podcast would become, or they didn't spend a huge deal of time thinking about it. I think it's unlikely that it would be on purpose, just because it has quite negative knock-on effects in the podcast client and on the user experience.
Yeah. And is it easy to change metadata after it's set up, or is it kind of, are you stuck with what you have?
You know what? I actually don't know. I would assume that you can change it, but genuinely, I would have thought if anybody else can answer that question, do feel free to jump in.
Hi, this is Johannes. Thanks for the talk. Concerning changing metadata, I don't know if this is even legal because it's coming from the publisher. So if you start messing with the metadata, I don't know if you can even do that. I have another question. You showed now different types of metadata of fields in the feed. Did you also do some research on chapters and how this is distributed, or how this could be used for recommendation?
No, actually. I don't know if there's anybody else who's looked at chapters, but no, I didn't look at chapters as part of this analysis, I'm afraid. I looked at categories and didn't include that as part of the presentation, but that is in the paper, but not chapters. Okay, any other questions, or shall we call that a finished presentation?
Are there any questions in the Whova? I see a question now in Whova. Have you looked into similarities between reality shows and podcasts in terms of listening, watching behavior, and might be recommendation techniques that could be used for both?
Reality shows. I have not. I'm interested in the idea, but no, I haven't, I'm afraid.
Yeah,
it's a question for me. So I thought since reality shows, they're also based on speaking to each other, there are like special techniques how reality shows are recommended and how people watch them. So there can be a parallel between podcasts and the reality shows in this sense. So I'm just wondering if you looked at that.
Alas, I'm afraid no, but it sounds interesting.
Right. Well, thanks very much, Matt, for that presentation, giving us all the problems. Next, we are going to go on to the Spotify podcast dataset, and Rosie will be presenting. Rosie, you're muted.
Okay, great. So can you see the screen?
Yes.
Okay, great. Thank you. Okay, so I'm very happy to talk about the Spotify podcast dataset. I worked on this dataset with my colleagues from Spotify who were listed here, Ben Carteret, Anne Clifton, Jussi Karlgren, Ashish Papusravanaredi, and Yongsoo Yu. Now I have to work out how to do next slide here. Okay. Yeah, so when I first started helping coordinate this workshop, I thought this workshop was going to be taking place in Brazil, and I was really excited to go to Rio de Janeiro. I've been to Brazil once before, to Salvador, but I've never been to Rio de Janeiro. And I started listening to a podcast about Brazil and learned about a classic Brazilian drink called the caipirinha. And I imagined myself sitting on a beach drinking a caipirinha, perhaps from a coconut. It was idyllic. And then I found this workshop, which was virtual, and it's delightful to be here with you all. But it got me thinking about learning more about Brazil by listening to podcasts. So how did I do this podcast listening? Did I do it, in fact, while sitting on a beach? Classically, when people are listening to podcasts, they're not doing it. Only 3% of people are doing it while not doing anything else or sitting looking at a view. Classically, people listen to podcasts while on public transportation or driving, while they're cooking, doing chores. And another way people listen to podcasts is while relaxing before going to sleep. That's one of my favorite ways. Unfortunately, that means sometimes I have to listen to a podcast more than once to get the whole story. And people listen to podcasts for a variety of reasons. A really common reason is to learn new things. In this case, learning about a country you haven't been to, learning about a technical skill you want to learn, but also for entertainment. And podcasts are growing in popularity. I think Qingwei gave us some statistics about this earlier as well. So if I wanted to do some other listening, say some more technical listening, I wanted to find podcasts about Brazil, I might also want to do technical listening about, say, machine learning. And there's lots of podcasts there, so how can I decide which one to listen to? And that's one of the challenges we find when we're looking for podcasts. And to date, people typically get podcasts via personal recommendation. Someone tells them a podcast that they think they should listen to. And clearly that's why we're here, to look into doing recommendation. So if we wanted to do it as a search task, so I have a specific information need in mind, we might ask ourselves, can we treat podcast search just like web search? Let's just say maybe treating like web search is a little simplified. Could we treat it like text search, say? And again, if we were all in Brazil in a conference room, I would ask you to raise your hands if you think we can. I don't know whether we even have a hand raising functionality here. But I think probably a lot of you will answer, it's not just like text search. It's not a solved problem with the existing technologies. And here's an example. So I work for Spotify. The CEO of Spotify is Daniel Ek. And as a good employee, I'd like to listen to an interview with him to see what he's saying about Spotify. There is, in fact, a very relevant podcast, and here's this audio file, what it might look like when I'm listening to it. But if we get a speech recognized transcription of it, we'll see it says, so I'm Daniel Ek, I'm the CEO and founder of the streaming company Spotify. But the speech recognizer doesn't recognize his Swedish last name and misspells it. So we have a mismatch between the correct spelling of his name and what's found in that transcript. So classic text matching techniques are not going to work in this case, or any other sort of content or other content-based methods. Now we can come up with workarounds for this particular one, for example, a phonetic matching, but more generally, podcasts are a relatively complex kind of entity. They vary a lot in format. For example, there are conversational and chatty podcasts. They're one-on-one interviews. Sorry, these statistics here are asking people to answer 3 kinds of podcast formats that they listen to the most. So that's why this can add up to more than 100%. So people listen to conversations, they listen to interviews, they listen to storytelling. So there's a lot of different kinds of formats, and people speak in different ways in these different kinds of formats. Once I find a podcast that might be relevant, I have a description that I can read, and this actually comes from the RSS feed that Matt was mentioning earlier. And I can look at that description to see if, to get a glimpse of what it's about and decide whether I want to commit my half hour or 1 hour to listening to this podcast. And so in the case of this Daniel Ek podcast, when we look at the description, it doesn't mention Daniel Ek or Spotify anywhere. So that alone is not giving us the information we need. So clearly we do need to look into some of the information contained in the audio file in order to be able to do real content-based recommendation or search. Here's another example podcast. This is about American football, something of interest to a small subset of the world. That's the show description, and this is an episode about Josh Gordon is Back, emergency podcast. And here's the description that those creators used to describe this podcast, which I guess we could paraphrase as Josh Gordon. So if you're a fan, this might be really meaningful, but if you don't know much about Josh Gordon, then this description that came from the creator doesn't really give you a lot of information to go on. So we started with one problem, trying to search for podcasts. Now we have 2, trying to get a summary to help us decide whether to listen to the ones we've found. I could talk very briefly about podcast summarization, how you might think about it. So let's say we take the transcript, or maybe we take the audio file, and we want to generate a summary for those that would be a good summary to help us in deciding whether to listen to that podcast. So summarization is a classically studied problem in the NLP domain. Typically it's being done on news or increasingly on Wikipedia pages and similar. But can we just use the existing techniques? If I could survey you, I would say don't count on it. And one of the reasons is that newspaper articles are written in a particular style where the opening sentence or paragraph summarizes the most important aspects of the story. And there's a word for it, the lead, which means that if you just take the first part of a news story, often that's a really good, strong baseline for a summarization. If we look in podcasts, the first 1 minute of speech can be any kind of thing. And so here's just an example podcast where the person starts by saying, I'm sleeping in bed, welcome to Debate Podcast. And then why don't you guys in the Twitch chat go ahead and suggest topics? So by the end of the first minute, they haven't even decided what their podcast is going to be about. So classic news summarization techniques may not be applicable here. So that leads us to the question, if only we had a data set for conducting research on these problems, and we decided to make it. So we worked with the National Institute for Standards and Technologies as part of the US Department of Commerce. The NIST runs the Text Retrieval Conference each year. It's an annual forum for information retrieval evaluation tasks and holds a yearly conference to present all the systems and evaluations. And very interestingly, for this case, they supply expert human evaluation to create label data and evaluate task submissions. So we released the first fully transcribed large-scale podcast data set with 100,000 podcast episodes, including audio, so a total of 2 terabytes of data. And we coordinated a new Trek task on podcasts. So this is the timeline. We're about halfway through the first year right now. We released that data set in April to people who registered for the Trek conference, and also the task guidelines, which were around search and summarization. There was an evaluation set released in July, and in September, we've just had submissions due, and we've updated tasks for a 2020 new proposed track. So throughout October, those submissions will be evaluated, and then we'll have that labeled data for building systems for next year. And then April next year, we'll be releasing an updated data set again to people who register for Trek, as well as task guidelines for the coming year. So let's just talk a little bit about what that looks like. This is the description on the NIST page for Trek. It describes the spoken document retrieval task. And they haven't changed the format of their web pages much since 1999. But in 1999, there was a spoken document retrieval task. And in fact, a paper published around that time in 2000 described it as a success story. So why do we think there's still some work to do on spoken document retrieval? And I want to drill down just a little bit into that. So there have been existing speech corpora. Why is this podcast data different? One way is that it's much, much bigger. So the first Trek podcast data set had only a few thousand stories that were with audio. The switchboard corpus, which contains people in conversations, was considered a very large open domain speech corpus and had about 110 hours. And the size of speech corpora has grown over time, but this is the first one of this magnitude, 50,000 hours. So it's an order of magnitude bigger than previous corpora. And what that means is that when you try and find a particular podcast in there, there are many other ones, many more to search through, and makes it a much more challenging problem. There's also a really wide variety of content. So there's varying levels of professionalism. And in fact, in this data set, there are about 10,000 episodes that come from professionally produced, really trained presenters who you can think of as being like newsreaders, or like people who would have the quality of journalism that you might see on a TV show. But then 90,000 episodes are from amateurs who can use a podcast creation app on their phone. We could get together on a Friday night with a beer and talk about things of interest to us. So there's a really low barrier to entry. Those people are using more colloquial language. They're using, they've got a wider variety of accents and a wider variety of topics. So that really makes it a very varied kind of content. And similarly, there's varying attributes from people speaking over each other, different background music, and different quality of microphones. The categories vary a lot. As I mentioned, lots of classic corpora contain news articles, but this ranges over a wide variety of things. Comedy is a really interesting and challenging section because we can't assume in comedy case that someone's really talking about a topic so much as mentioning a topic for its comic value. In the first year, we made a monolingual corpus, so where the creators annotated their podcasts as being in English, although as we learned from Matt earlier, the RSS feeds aren't always accurate, and things annotated as English aren't always in English. Longer term, there's plenty of podcasts available in other languages, and so we'd like to extend this to a multilingual corpus as well. As far as summarization, previous summarization data sets are also either smaller when they're on spoken corpora, or on news, again, which is a narrower domain. So just to talk in a little bit more detail about the data itself, podcasts come in shows, each show has episodes, and then we've got the standard RSS headers like title, description, publisher. And then we've also augmented it with the transcript coming from an automatic speech recognizer and the audio file. There's 100,000 episodes. Together with the transcripts and metadata, it's about 13 gigabytes. When we include the audio files, it's 2 terabytes of data. And the documents are relatively long. They're on average about 5,700 words if you look at the output of the speech recognizer. And some of them are really long. Some podcasts, we truncated some of them at 90 minutes, as you can see from this distribution, because they're such long. They have the potential to be so long. And when you look at the transcripts, they're generated using third-party high-quality speech recognition. So we have timestamps for each word. We've also got speaker tagging. So there's an automatic guess at who's speaking at each word, which can allow you to break conversations into their individual speakers. We've also got inferred punctuation and sentence segmentation. And we've got some more details on this in our archive paper. So just to sort of come back to this original problem, what we'd like to see happening is I have some sort of information need, like I want to learn more about Rio de Janeiro, Brazil. I'd like to get back a relevant podcast and also some kind of summary of that. Say, in this part of the episode, you learn where to get a great caipirinha in Rio de Janeiro, and well as some Brazilian Portuguese phrases to use while you're there. That's where we'd like to be. And in fact, we've got a couple of people speaking later in the workshop about the summarization experiments they've done. So what's not in the data set? There's no user data, there's no listing history, and there's no interaction data. And that's partly because of our evolving understanding of privacy concerns. And we thought there's a lot of research problems that can be done with the data set, just going on the content of the podcast themselves. So what else should we do with this data set? There's all your favorite NLP problems. And now we'll have this ground truth for summarization. All your favorite search problems, and now with some ground truth for passage search. All your favorite speech problems. And then I'd like to propose that we collaboratively build a data set for recommendation. So make sure you attend the workshop activity this afternoon. That'll be happening at 11:40 my time. And to give you a few different time zones, 15:40 UTC, which is I think what we're working is our workshop time. 11:40 EDT, 12:40 in Brazil, 17:40 Central European time, 3:40 AM Beijing time. That's a bit challenging for people in Beijing, but surely it's caipirinha time somewhere. So, obrigado a todos. Thank you.
Thanks, Rosie. That was great. Let me take a peek in Whova to see if anyone has any questions. Or actually, if anyone has any questions on the line, let's start with the room first.
Yeah, I had a question concerning the corpus, how it was produced. I think Rosie mentioned it shortly with RSAir, but can you talk a bit more about building up the corpus?
Yeah, sure. So let's see. So I guess for all of the podcasts in the data set are owned and operated by Spotify. So that's one constraint. So they typically come from various, Gimlet is a company that's owned, or a company that's owned by Spotify. Anchor is a podcast creation service owned by Spotify. So that's one constraint. Then if they're not owned and operated by Spotify, they won't be in the data set. We did remove some episodes that we thought could be problematic for various reasons. We had some random sampling in there, but tried to keep that distribution of 10% of the sort of higher quality ones and 90% at the tail of the distribution. And then we verified that at least the creator thought they were in English. As we look into the data set, we find they're not all in English anyway, because that's not always a correct annotation. And we didn't particularly sample We didn't sample all of the episodes per show. There are a number of shows that have multiple episodes, but we don't necessarily have all the episodes for any given show. Do you have any more specific questions than that?
Yeah, what kind of technology you used, which error rate you accepted.
Oh, sorry, on the speech recognition itself. I see, yeah. I see. Yeah, so we used Google Video ASR. I think it had about 18% word error rate. And we also measured a named entity error rate. I don't have that number in mind, but it's in our archive paper.
Okay, cool. So the archive paper is available in the description of this workshop, or where can I find it?
Jingwei, is it linked? Well, if it's not linked from the podcast, from the workshop page, we will link it. Yeah.
Okay, then
go to the Podrex workshop website under accepted papers. You'll be able to.
Yeah, we can put it in the chat in Hoover for my talk afterwards as well.
Oh yeah, that's good. There is one question from Hoover, which is, how does this podcast dataset differ from the one released for the RecSys challenge in 2018?
Okay, so well, the first answer is the RecSys challenge in 2018 was not podcast data. Qingwei, do you want to elaborate a little bit about what the dataset was about?
It was about playlists, and so it was a list of 1 million playlists, which is a set of tracks and a title for the playlist.
And specifically, so the titles of music songs, and
that's right.
There were probably no podcasts in that, right?
That's right. And yeah, this one is also, the podcast dataset was kind of released in conjunction with the Trek Challenge, which is the annual NIST challenge series. And yeah, the previous RecSys challenge was just released with the RecSys challenge. Let's see. Do we have any more questions for Rosie? In the room, maybe? Okay. Great. Well, thanks again, Rosie. And Rosie will put the link to the archive paper in the Hoover chat. So thanks. And now we will move on to our next speaker, who is Rachel Zhang. And she will be presenting their paper, A Baseline Analysis for Podcast Abstractive Summarization. Oh, and this is pre-recorded, so I'm gonna play this.
Rachel is here for answering questions.
She is here though, and she's here to take your questions after the talk. All right, so let me get this going.
Hello everyone, my name is Rachel, and I'm currently a third-year PhD student at the University of Delaware. It is my great honor today to present our work, A Baseline Analysis for Podcast Abstractive Summarization. This paper is a joint work with my advisor, Dr. Harry Wang, Dr. Kunpeng Zhang, and Dr. Ling Fan. Podcasts have become one of the fastest growing online audio streaming medium. According to the national survey from Edison Research, as of April 2020, there are over 30 million podcast episodes from over 1 million shows. 55% of the US population has listened to a podcast, and about 24% listen to podcasts on a weekly basis. The rapid development of podcasts has stimulated demand to understand the unique features of the podcast. Comparing to the increasing demand, however, the discovery and understanding of the podcast content seem less progressive comparing to other types of medium, like music. So in our short paper, we focus on how to understand and summarize the podcast, which serve as an important input for podcast recommendation. Accurate and precise summary could help us capture the key information inside the podcast. We aim to share our preliminary results on data preprocessing and some baseline analysis to explore the unique feature of podcasts. We try to answer the following research questions. Number 1, is podcast itself unique or challenging for summarization tasks comparing to other data sets? Number 2, if the answer for the first question is yes, which features of podcasts challenge the current approaches and how unique they are? Number 3, how can we learn from these features and possibly improve our performance in future research? We expect our paper could help researchers understand the current state-of-the-art summarization models and build a foundation for creating better models. The dataset we use is a recently released Track 2020 Spotify podcast datasets, which consists over 100,000 podcast episodes with audio files, transcripts, episode summaries, and other show information. The original dataset is preprocessed by the podcast track organizer by removing episodes with descriptions that are too long or too short. Also, duplicated episodes with similar descriptions are removed. This dataset, which is called Dataset, contains about 66,000 podcast episodes. Starting from the datasets, we observe some unique features of the podcast. Podcast itself is audio streaming medium, which provides multimodal features including text and audio. Since most of the summarization corpus rely on text only, in our paper, we only use the transcript to summarize the podcast. We hope to see more researchers using multimodal features to better understand the podcast content. The second feature is the length. The average duration for the episode in our dataset is about 30 minutes. In terms of the transcript, we have around 6,500 words on average for one podcast episode. Here I list a table to compare the average number of tokens between the podcast datasets and other popular summarization datasets, including several news datasets, CNN Daily Mail, New York Times, and the pattern file, big pattern datasets. It is clear to see that the length of the podcast is much longer than others, which actually brings a lot of challenges. Besides the length, the style of the podcast is more conversational and colloquial. In my opinion, typically there are two types of the summarization datasets, news-related and others. News is the perfect corpus for summarization task since it is short and sharp. More datasets are proposed in recent 2 years, including pattern files and academic papers, within the focus on handling long document summarization. But all these datasets are professional edit texts. Comparing to them, the unique style of podcast makes the summarization task much more challenging. Also, the podcast transcript is noisy with commercials and sponsorships. Combine all these features, we can find using transcript to summarize podcasts is much complicated than other corpus. So based on these unique features of podcasts, we perform additional data preprocessing. Using Dataset, we first remove emoji in the description and filter out episodes with too short emoji-free description. We also remove episodes longer than 60 minutes in this paper, and this constraint can be easily relaxed if necessary. We filter the episodes whose description contains profanity language or is not written in English. After performing these steps, we preprocess the episode description. We perform rule-based filtering to remove the sentence with social media information, sponsorship or advertisements, website links, and email address. Then we remove some episodes if their clean episode description is too short. After preprocessing the datasets, we firstly design two simple baseline models. We select the first K tokens and the last K tokens from the transcript as a summary. For evaluation, we use the root score and treat the episode description as the golden standard. This also explains why we prefer rule-based filtering to remove the sponsorship or social media information, because we think those are irrelevant to the key information of the episode. This episode description are written by creators themselves, which means the quality varies. So our preprocessing is trying to improve the quality of the golden standard. The key intuition behind our baseline models is the beginning or the ending part of the podcast may contain more important information. The result also serves as a baseline for future model comparison. Here is the result for our baseline models, and we choose K varies from 100 to 500. We can observe a clear pattern from the result that longer summary tends to capture more words and faces from the ground truth, which often leads to higher recall but lower precision. There are two key takeaways here. First, choosing K equal to 100 yields the best combined F1 score, which means 100 tokens are long enough to capture the major summarization information. This is compatible with the description of the true summary, where the average summary length is 44 tokens and the maximum length is 144 tokens. Second, baseline 1 has the highest F1 scores, which means the starting part of the podcast contributes more than the ending part to the summarization task, which also means that the starting part contains more useful and related information. This is also consistent with our observation that podcast episodes often give some overview at the beginning to tell the listeners what to expect. After building baseline models, we conduct several experiments on current SOTA summarization models using the podcast datasets. We want to test their performance to see if the current SOTA models could handle the unique features of the podcast. The goal is to get an overview of their performance, which builds a foundation for better model innovation. We choose 3 models: BART, T5, and ProfitNet. For each model, we use the pre-trained model, fine-tune it using the CNN and Daily Mouth dataset or the pre-processed podcast datasets. We split the podcast datasets into training, validation, and testing sets by 60%, 20%, and 20% and random. Because all 3 SOTA models are transformer-based, the length of the transcript is much longer than the maximum length of sequence. So the input sequence will be truncated during training if it exceeds the maximum length limit. The model uses the input transcript to automatically generate the podcast episode summaries. Then, the generated results is compared with a clean episode description, which is evaluated by the root score. In this slide, here is the result for SOTA models. We use the first 100 tokens and the last 100 tokens as the baseline models. We have several conclusions based on this table. First, the performance of 3 SOTA models is comparable to the baseline models, which indicates that there's a plenty of headroom for improvements and calls for more research in this area. Second, the performance of these SOTA models on podcast datasets has a huge gap between their performance on the news datasets. This could imply that the podcast summarization task could be more challenging. Also, fine-tuning on news datasets may result in lower performance compared with the vanilla pre-trained models like BART and ProfitNet in our example. This brings us some thinking about the lexicon difference between the podcast and other existing datasets. After presenting these results, we'd like to have some discussion about podcast summarization and the potential future directions. Podcast summarization is interesting and challenging. Considering the futures of podcasts as we discussed, podcast summarization is a combination of long document summarization, conversational corporate summarization, and the multimodal corporate summarization. It brings us plenty of research opportunities to design an efficiency framework reflecting these features. Also, We believe effective evaluation for podcast summarization is desperately needed. Road score may not be good enough for a podcast summarization task based on our experiments for two reasons. First, for the podcast, the ground truth is hard to define and noisy. Road score focuses on the overlapping between the generated result and the ground truth. Noisy ground truth leads to a biased result. Also, in a recent paper from OpenAI, they also bring up that the road lacks the efficiency measurement of summary quality. So how to define effective evaluation metric for podcast summarization is an important research question. So this is my presentation today about our paper. We present the performance of podcast summarization using 2 baseline models and 3 SOTA models on the Spotify podcast datasets. We discuss several potential directions for future research in this field, and we hope this paper and our implementation can help researchers make more innovation in this exciting research area. Thank you so much.
Thank you, Rachel. That was a great presentation. Let's see, does anyone in the room have a question for Rachel?
Yes, I have a short question. You mentioned that you filtered out some of the stuff in the corpus for your before you did your experiments. Could you go over that again? What were the ones you took out?
Sure, absolutely. So let me try to share my screen. Just want to check, can you guys see my screen?
Yes.
Yes.
So basically, we perform some data preprocessing. So based on some features we discussed from the datasets. So firstly, like Rosie just discussed, like some datasets they are not English, like they may have some emoji. That's basically a common feature for podcasts. So we filter out this episodes to try to have try to have a clean data set. And I'm not pretty sure when you talk about the filtering, you're talking about filtering these episodes, or we try to clean the episode description, which serve as a ground truth for evaluation. But for filtering out the data sets, basically we just set up some rules and we try to have a clean data set here. And definitely we think a very important step in our paper is trying to clean the episode description, because podcast has a lot of unique features. So basically we try to remove like the social media information, the sponsorship, or like the website links on the email address in the episode description. We try to, because episode description serve as the the ground truth when we evaluate it. So we try to remove those biased information.
I get that. So yeah, taking out the formulaic stuff, the stuff that doesn't seem to contribute to the episode description itself, but taking out the emojis, isn't that a bad idea?
Yeah.
And taking out the profanity, I don't quite see why you would want to do that. But now I can't see the number. I can't see the numbers on my screen now.
I'm sorry.
But I'm on a mobile here, so it's my fault rather than yours. But
maybe a follow-up question is a huge number, like 10% had emojis in the descriptions. Could you talk a little bit about what kinds of emojis showed up and why you thought they were not relevant?
So basically, it's because I think when we have the preset, which is cleaned by the podcast track organizer, they set some rules. If the episode description or show description is too long or too short, we will just filter them out, right? But based on our research, we find out like even when we try to filter out this too long or too short episodes, there are actually some episode descriptions only fills in with emojis, which means that if you just try to count the length of the characters, they are long enough. basically they contain no useful information. So that's the reason we try to remove the emoji and then figure out the too long or too short. We just try to, perform the preprocessing again. That's the reason.
Thanks. Hongyi, did you have a question?
Oh yeah, so my question was actually regarding the evaluation. So you also mentioned that the Roche score is kind of limited in terms of measuring the similarity between your model output and the ground truth, I guess. So when you think about integrating human into this evaluation, so what kind of things are you thinking about? Are you thinking about like asking them to manually label some of the model outputs, or are you trying to use some kind of implicit feedback, like is it relevant or not relevant?
Gotcha. So I think this is a very good and very interesting question. So basically, during my last 2 to 3 months, I contribute all my time to try to summarize podcast. So the Roche evaluation, to be honest, bothers me a lot because the buyer's episode description, even we set up some rules trying to figure out some like social media sponsorship and advertisements, you can see the performance is still. I mean, if you compare to the new summarization task, we still have a lot of room for further improvement. So at this time, to be honest, I don't have a pretty clear plan to how to involve human feedback into the model because as a PhD student in university, we cannot compare with OpenAI, to find so many people to label those data. But we're still thinking about our next step is thinking about involve some weight classifier by introducing more evaluation like Roche, like a perplexity score, like other those measurements try to involve to be like an ensemble-based evaluation metrics. So that's our current plan, trying to simulate the human feedback from those scores, those metrics.
Mm-hmm. Thank you.
Okay. Well, great.
Sorry, I have another question.
Yes, go ahead.
Right now, as I understood, you only worked on the episode descriptions, right? Rachel?
Yes.
Did you also try your models on the transcripts that were provided from Spotify dataset? Or were there no transcripts available?
Sorry, I think my network's a little broken here. But we use the transcript from the Spotify datasets to generate results and compare with the episode description.
Okay, good. I didn't get that. Thanks.
Yeah, they did use the transcripts.
Okay, cool.
That was the input. Yes. Okay, thanks everyone. So let me just remind everyone that thank you to all our speakers. We are now at the break, and I wanted to remind everyone that we have a very fun activity coming up in 30 minutes from now. And the question for you is, what are 3 podcast shows that you really like? And so now that you've had a little time to think about it, write them down somewhere on your local machine. Just write them down. And at 3:40, in 30 minutes, we'll come back for the activity. And so in order to do the activity, we're going to have to use breakout rooms, which doesn't work through the Whova interface. So if you go to the Whova chat box, we will post the Zoom link to come back to the activity. So it's the same room, but you'll come through your Zoom client. So we will post the instructions for the activity as well as the Zoom link in the Whova chat. So we'll do that right now, so you have it. And if you don't have it, you can come back in 30 minutes and get it there. So have a think about this, take a look at the instructions, and we'll see you in 30 minutes. Is there anything else I need to say, Rosie?
Oh, that sounds great.
Okay. Well, thanks again, and see you very soon.
Jingo, you might just want to leave that instruction up as a slide, so if people are popping in and out, they get the...
Yeah. But then I can't. I'm going to pause the recording.
To know each other, we thought that since we're not together drinking caipirinhas on the beach in Rio de Janeiro, we need some other way to interact, but meet other people who are also interested in podcast recommendation. But simultaneously, we want to use this opportunity to sort of learn something about podcast recommendation, perhaps record some of the things we learned, and perhaps think of a way of working towards building a shared podcast recommendation data set. So I'm hoping that you've all picked out 3 podcast shows that you like. They can be, and if you find it hard to pick your best 3, an arbitrary 3 will do as well. But 3 that you know, maybe 3 that you've listened to, or 3 you aspire to listen to. So now, oh, there. So just to give a quick overview of what we'll do, some of you may have read the instructions in detail. Other people I know like to spend their break having a break. So assuming you're just fresh back. We'll ask you to collect 7 random podcasts, and we've got a random podcast generator to give you those, and you'll mix those in together with your 3 chosen podcasts. Then we'll ask you to join a breakout room with 2 to 3 other participants. So that's why we want you directly in Zoom, not watching from Hoover. So if you're in Hoover, understand that's the way RecSys sets it up. Have a look in the chat. There's a direct Zoom link. Please enter via the direct Zoom link so we can put you in a breakout room and you can join the activity. In that breakout room, you'll ask each other questions and try to guess each other's podcasts. And along the way, we'll learn something about podcast recommendation. Just a little word about confidentiality. We'll be asking each other questions, and some information may be helpful in recommendation. For example, knowing how old someone is, what language they speak, what religion they are. You could probably think of other things. But on the other hand, people might consider those things private. So there's a little sort of we've got to sort of balance that. So feel free to decline any question you're asked. But also, as we're asking each other things, keep any answers you learn confidential to your breakout room. And we'll be giving sort of aggregate summaries of what we learned in our breakout rooms. And mainly just be respectful and make sure everyone's having a good time. So just wanted to, this is we're going to sort of step through the steps. Has everybody got their 3 podcasts written down? 1 minute. If anybody else needs to do that, you can raise your hand. Oh, there we go. Nice thumbs up from Jordan. Okay. So now you can collect 7 random podcasts. This is a nice app that Chingwei set up earlier. If you go there, it'll just generate 7 random podcast names for you. Write those down, and then your task is to mix them up with your 3 chosen podcasts so that people don't know which ones are yours. And some people might have done this over the break. Maybe a couple of people are doing it now. I'll give you another few seconds to do that. Maybe raise your hand if you've got that done and you didn't have it done before. Chingwei, I'm not looking at the participants, so if you see hands going up, can you let me know?
Just speak up, actually, because I think there's some people's hands are up because we asked them to raise your hands. So if you have,
okay, you can lower them all again if you want to.
I can do it in chat as well.
Yeah.
Oh, I can lower them all.
Yeah, I think so.
Lower.
And you'll have a chance to do this in the breakout rooms as well if you haven't done it already. So now we're going to get ready to join our breakout rooms. Just a quick synopsis of what you'll do in that breakout room. Introduce yourself briefly, but don't say too much because some of the information people might use for recommending podcasts, but maybe your name and where you work or study and why you came to this workshop. In your group, you'll assign someone to be a note taker. That person can open some document to take notes. The first person can paste the mixed up list of 10 podcasts in the breakout room chat, and the others can ask a few questions, and then we guess. And then we just want to discuss, did they get it right? What information did they use? Did they use any information that wasn't in the questions they asked? And then everyone take a turn. So you can take about 5 minutes each to do the guessing game. And then as a group, summarize what you learned for the group discussion. And so remember confidentiality, so don't record names and answers, but just general things you learned. Maybe you learned that age is relevant, or that language is relevant, or that those things didn't help you as much as some other kinds of information you use. So we'll allow about 30 minutes for that whole exercise. So maybe 5 minutes each person, and then 5 to 10 minutes to summarize. And then designate a speaker in your group to summarize for the session. And then we'll come back here to the main group at the end of 30 minutes And we'll do some lightning talks. So the speaker from each breakout room will have about a minute or 2 minutes to talk about what they learned and you know, thoughts about making a podcast recommendation at Dataset in the future. So Qingwei, how many people have we got in the Zoom here? And do we want to give a minute for anyone else to move from the Hoover directly into the Zoom? When you do the breakout rooms button, it tells you how many people there.
Okay. Oh, we have 16 participants.
Okay, so
that I can break up, but there are 35 in the
that
whole
includes some people from on Hoover. Come on, Hoover people. Come on over.
Come on over, and if you come, you know, if you take a minute, I can put you into a room too. But
okay, so if people arrive a little later, we can add them to rooms. Yeah.
All right. So we have 15 participants. I'm going to make 5 rooms.
Maybe make 6 rooms so there's a.
Yep.
Because also we organizers can join a room as well.
Yep. But then the 15 is including organizers. And so some just have 2 people.
Okay, so maybe make it 5.
I think I'm going to go make it 5.
Yeah.
Let's see. Yeah, that looks better. All right, let's try this.
Okay, shall we do it? And set the timer for 30 minutes then.
I don't know.
Oh,
I think that's already, I think that was
okay. I think it's
already done.
Great. See you in the breakout rooms.
Welcome back to the main room. Let's wait for people to filter back. Let me see the breakout rooms. Cool. I can see rooms 1 and 5 have come back. 2, 3, and 4 are still in there. Ah.
I made the screen big. You can get back to the.
All right. How do I broadcast the message? Let's leave the breakout rooms as. Okay.
So how many breakout rooms did we have? So how many?
5.
Okay. And the time we're scheduled to end in about 10 minutes. Is that right? This part of the workshop. So we've got 10 minutes for this.
No, we have 20 minutes.
Oh, we've got 20 minutes. Okay, great.
Rosie, meanwhile we are waiting for the others. The data set that you created, the corpus for the track conference, is it also available for other people to play with, or only for the participants of the conference?
Yeah, so we're now, the original data sharing agreement, the legal agreement we had was only for people participating in the conference, but we're now working on rewriting that, and we're hoping to make it more generally available relatively soon, let's say in the next month or 2. So that would involve then sort of signing an agreement saying you won't use it for commercial purposes, that kind of thing. So not yet, but soon.
Okay.
Yeah, because we're also trying to create our own data sets, but yeah. I think resources are limited in a small company comparison to Spotify. Yeah.
All right, let's get started with the discussion. We need to get 1 designated speaker from each group. If you are that person, please raise your hand in the in Zoom. And I'm just going to go from top down. So first we have Luke Haushalter. If you'd like to share what you learned from your group, what questions worked well, what information did you use that you didn't ask?
Yeah, absolutely. So it was more of a pairs exercise for us. It was just the 2 of us. It was me and Rachel Zhang, who had a talk earlier. So we, one thing we did notice is that the podcast kind of fell into specific categories. So the guessing, it became kind of a matter of, you know, can we eliminate one of these buckets? You know, if there's a true crime bucket and a news bucket and kind of a media bucket, can we just remove one? So that's kind of where our questions came in to see if we could kind of remove those. There's obviously some demographic information we could get from looking at each other, you know, relative age, and then obviously there's a certain understanding that, since we're at this conference, there's probably like a guess about education level and kind of class in that sense. So those kind of helped us to determine, and another factor that wasn't, it was hard to, or that we didn't include in our questions, but that was important, was knowledge of the podcast. So I knew a few more in Rachel's list than she knew in my list. So it was easier for me to kind of determine what would be hers and what wouldn't be hers. I don't know if there's anything else that you wanted me to touch on.
Oh, that's very interesting. Thank you. Jigme, do you have any other questions?
No, just curious if other groups found similar things, different things. We'll get to each group, but just since this is kind of round table discussion. Did you get them right?
I got 3 for 3 and Rachel got 1 for 3.
Wow, amazing.
Oh, did you look them up? Like, did you Google them?
Yes, I actually looked them up on Spotify and I looked at the descriptions.
Okay.
Does Spotify has all the podcasts from the iTunes directory, or is it limited?
In general, there's very rare ones that there's some different licensing conditions, but in general, we have, I think, most of the podcasts that there are.
Yeah. Shall we move on to Ghazal?
Sure. Yeah, so our breakout room was Anish, Thomas, and me. So first of all, I want to say that it was really interesting to see that all the participants in our breakout room had wanted to have precise names for the podcast that they want to put in, so that they don't give it away, or the punctuations and the semicolon at the end. So it was nice to see that. So one of the main things that helped us guessing the other one's podcast was popularity. So we all had favorite popular podcasts in our list, and those were actually the ones that we guessed first, and it was correct. So following up on what was said just before now, knowing the description of the podcast would have helped us a lot. We didn't look up the podcast, so we just tried to guess based on the names, and that's why some of the names were helpful. Reading them, we knew that maybe knowing that person's background, that's not something that they would listen to. But if we had maybe a summary or a description for the podcast, that would have helped us to make the decision. And background and the interests that each participant introduced themselves with helped a lot. We all are working in tech, and some of the podcasts that are favorite to us are the ones that are related to this. Another thing that we noticed was the type of the podcast that we all picked as our favorites were the ones that were kind of adjusted to our types of lives. Like, we discussed this a little bit at the end, that maybe not just the length of the podcast, but the content of the podcast. That's not like chit-chatting of a couple of people's, but a more tailored content by a well-known publisher or producer that actually was something, an indicator of what we would pick and listen to. I think those are the main ideas that we discussed. Is there anything else, Anish or Thomas, that you would like to add to this?
Sure. I'd just like to reinforce the interests side of this, because once we heard about interests, it was pretty easy to filter some out, or at least pick out some.
Yeah, that makes sense. Cool. How about Matt?
Yeah, we had, by and large, we did relatively well in terms of getting them right, but we did look them up. And I think our most successful question was, why do you listen to podcasts? And then that helped us. So then we formed clusters out of, you know, these are true crime podcasts, these are sports podcasts, these are learning podcasts. And when you know that somebody listens to podcasts because they like to learn, that really narrows you down. So I think those are our most successful questions. Other ones that were useful was, I guess, the job that people do, their hobbies, and we found gender to be not always right, but sometimes steering us in the right direction and sometimes steering us in the wrong direction. So interesting, at least. And I don't know if anybody wants to add anything else.
Well, I think, like someone mentioned earlier, the fact that someone is at RecSys, we used to say, okay, they may have more technical background. And so when there were technical podcasts, that was helpful.
Yeah, when we did the dry run last night, we found this, like, why do you listen to podcasts was also a very interesting question. It's not very specific. It was so hard to not ask, like, you know, you see the anime podcast, like, do you like anime? Like, those just seem like too direct. But, you know, why do you listen to podcasts is a fairly general question, but I think it helps narrow down a lot.
That's a good point. That was actually one of our results, like at the end of the discussion that we had. We kind of realized that that type of questions would have helped us, because we realized that some of us listen to podcasts to learn something new or to just pass time in the commute, or yeah, that would have been a good indicator.
Great. Thanks for sharing. Let's move on to Brian.
Yeah, so I think first of all, we shared a lot of the things previously said around like interests. So we asked about like whether they were into sports or politics, and that those kind of things usually narrowed down the field quite a lot. Also, once you got a single answer correct, it could help sometimes to get another one. So if you knew that they were into sports, there may have been like a second sports podcast, or if they were into tech, again. And as like everybody else, the tech context was the fact that we're just at RecSys was super useful. There was stuff around Stack Overflow, things like this. As soon as, and those are relatively rare, I would imagine, in the overall like Spotify catalog, say, but specifically more popular among maybe this community. So you can kind of make an educated guess that that's maybe the outlier. One thing that we found quite interesting actually was around language and nationality and stuff. So we had sort of a very diverse group, and we sort of asked around where the people came from, where they lived, and what languages they spoke. And actually it wasn't always, those things can provide different levels of accuracy. So actually it wasn't usually the language, it was more like where they actually came from. That was, and where the podcast hosts or where the podcast is based versus where the person comes from was actually kind of more indicative rather than just the language of the podcast itself, which was quite interesting actually. And then lastly,
could you elaborate? Yeah. I was just curious. I'm trying to make guesses, but maybe you can tell us. Are we talking about sort of English language across different countries, or what would be sort of examples of that?
So I guess English across different countries was one example. So there was one where like I was into politics generally, but there was one specifically from an Irish setting, and I'm from Ireland, don't live there all the time. So that would have been quite an easy one to guess once you got that context. And the other one, Fernando, if you don't mind me saying, was from, it was Spanish language, I think, right? But, yes. And there was one with Venezuelan hosts. And Fernando is originally from Venezuela, but now lives in Italy. So if we only knew the Italian context, we wouldn't have gotten that. If you just knew the language context, you might have gotten that. But if you knew the Venezuelan context, you for sure had a much stronger signal there. So that was kind of interesting. And then the last one was just, it was a lot easier to rule things out than it was to go through the list and sort of remove segments or remove interest groups. than it was to actually trying to narrow down a single one. So that was it from us.
Great, thanks. And let's go with Jordan.
Hi, so yeah, we found a lot of the things that the other groups have already presented. So all of us kind of started by asking these very genre specific questions, and we found that was sort of useful as a first pass, but wouldn't get you all the way there, and sometimes was even sort of a red herring. For example, Longshi said that he didn't like comedy, and so that ruled out one of our choices, Wait, Don't Tell Me, but then he's like, oh, I don't think of that as a comedy podcast. I think it's and so the way that we define genres is actually quite different person to person. We also found that things like where people listen, whether they like to focus exclusively on listening or whether they like to multitask was actually quite helpful for us. And we also use this why do you listen question a lot. And we focused on this kind of like, are you listening to learn or listening for fun? However, we found that would have been more useful had we had more knowledge about the podcasts themselves. So like, for example, we were trying to decide between 2 history podcasts. So we're like, oh, which one is more sort of immersive and which one is more something you can put on in the background? We weren't really able to answer that question. I thought it was also interesting that in our group, we found that the interests you have in your life don't necessarily match up one-to-one with the interests you have in your podcast self. For example, Maureen said that she didn't meditate, and yet one of her podcasts that she liked was actually about meditation and about mindfulness, but it wasn't like a meditation podcast. So I thought that was quite interesting, and we had similar examples from all of our participants. So yeah, it was super fun. And I would say we were mixed. Like we always got at least one, usually 2, but there's no one that we got like 100% right. Did anyone else in my group have any things that they wanted to add to that?
Yeah, thanks, Jordan. Just to add on to Jordan's point. So one more thing, as you were talking about the context, that we find it helpful that at what particular time, you listen to a particular podcast. So that also helped us to infer, what type of podcast they would be interested in based on the context and the timings and the location. So I think that could also contribute to that.
Great, thanks for sharing. We have a couple more minutes until Jordan's keynote. Rosie, I don't know if you want to bring this all back together and remind people to put the notes in the central doc.
Yeah. So we if you were in the long written instructions at the very end, we had a link to a document to kind of dump some notes if you've got a little bit of a summary that you wrote up for sharing. And actually, maybe we'll put that in the chat now.
I can do that.
Great. And the other thing, we've got a couple minutes. I'd just be interested in knowing, so we had early stages of planning this workshop. We had grand visions of people, doing this in a more public way. So everyone puts in their list of podcasts and then we share that with other, make a sort of collective data set. In the end, we felt like that, because of the privacy concerns, we'd need to be sort of more cautious about that. But I'd be interested in knowing if people would be interested in contributing their podcast listening history or the podcast interests or lists like this to some shared data set, and maybe with some other kinds of information that then we could sort of start to build one in a collective way, and maybe we can go out to bigger groups. So just sort of curious for comments on that.
Sure, I would have no problem with this.
That sounds wonderful.
Yeah, okay.
Yeah, happy to share.
Sorry, I think it depends on what level we want to record these preferences, like whether we want them at episodic level or at the series level. I think that could also make a big difference in how people perceive privacy versus being willing to share.
Can you elaborate what level you think is more or less concerning?
Yeah, so I think talking about series is fairly straightforward, like no one should have a problem saying, hey, I like Planet Money, but talking about, hey, I really like this episode is something a little more personal. So I believe people may have a few more reservations. divulging that sort of information.
Yeah. Yeah, I think the assumption is we wouldn't associate any, ultimately, like maybe in the process of building it there might be, but we wouldn't ultimately associate names with it, but then the other information like the demographics can sort of help re-identify someone. So we need to think about that. So that's a really interesting point. Yeah. And we've got 1 more minute. Any other comments about thoughts about making a shared data set?
Actually, we had talked about creating a community, like a Google group, I think was the idea. Do people think that's a good idea? And we can maybe take this sort of data set idea on there and people can contribute ideas. Should we do Google group?
Sounds
good. Yeah, it works for me.
All right. Great. Well, thanks everyone. And thanks, Rosie, for facilitating this. I think it was kind of a little bit of a dream at the beginning, like, oh, we should make, this is the first workshop, we should make it, interactive and like really get people involved, and didn't really know quite how to do it. And Rosie stuck with it. And I think it turned out really well. It was super fun. Yeah, for me too. So thanks everyone for participating too. It wouldn't have worked if you weren't, open to it and sharing. So thanks everyone. Let's then now shift back over to the program. What am I gonna do here? And so, yeah, actually, well, I am very honored to introduce Jordan Wirfs-Brock, who's our keynote speaker for today. And she will be talking about what do we really know about podcast listeners. And Jordan, I'm going to hand the screen over to you.
Okay, hold on, just getting set up. I had to run around and close all my windows because it's garbage day and there's garbage trucks.
Okay, yeah, go for it.
Around. So give me 1 second to, oh, where did Zoom go? Okay. Sorry, there's always the juggling of all of the windows. That must happen.
But maybe we can do a little bit of a background about how we know Jordan. Jordan did an internship at Spotify a couple of years ago and did some really interesting work while she was here. And I think the work she's talking about now has come from an internship at Netscape, right? So
Mozilla.
I'm sorry, Mozilla.
Yeah, so I think I'm ready to share, but it says I can't share while you're sharing. So, okay, there we go. Share screen. Okay, are you all able to see the presentation?
That's cool. Okay. And we have split screen. That's nice. How do you do that?
I don't know. Are you just seeing the presentation and not the speaker notes also?
I don't see the speaker notes.
Okay, cool. All right, awesome. So, all right, well, thank you. Once again, I'm Jordan, and I'm super excited to be here. So thank you so much to Cheng Wei and Rosie, our organizers. Thank you for inviting me. I did have a chance to look at the workshop papers, and it's super interesting work. So even though I'm not a recommender systems person, I'm definitely a huge podcasting person. So I'm just really excited to share some of the things I've learned with you today. So I'll be talking to you about what I've learned about podcast listening behaviors, as well as leaving you with some open questions and provocations that can hopefully, I don't know, provoke some interesting discussions about how we think about recommendations for podcasts and other audio content. So a little bit more about who I am. So I am a PhD student in information science. So I focus on human-computer interaction. And I do a lot of work with voice assistants and conversational interfaces, and also something called data sonification, which is like making a graph, but with sound. So I'm a very much a sound and audio oriented person. Before that, I worked as a data journalist in radio and TV. And when I'm not working, I'm probably either listening to podcasts or playing board games or running really long distances in the mountains. Sometimes a combination of those activities. So because this is like the one place where I get to super nerd out about podcasts, let's jump into that identity as a podcast nerd a little bit more. So I'm both a listener and a creator, a sometime creator. So this list is by no means exhaustive, but by way of introduction, here are some of the podcasts that I'm into now. Imaginary Worlds, Reply All, The Last Archive, Make Me Smart from the Marketplace folks, and Bird Notes, and many, many more. And then I've also produced some podcasts in the past, including an episode for Out There about a 10-day trail race I ran, and Qualia, which is sort of an avant-garde podcast which explores philosophical questions through immersive audio and some strange techniques like role-playing and things like that. All right, so the main themes that I'm going to talk about today. So first, I'm going to talk about how people discover content and how it happens kind of within this ecosystem of discovery methods. And then I'll talk about some of the ways that people listen, the devices they listen on, the apps they use, how much they listen, and focusing on how enthusiasts and newbies are actually quite different. After that, I'll talk about how listening isn't just for strictly audio content. People actually listen to videos quite a lot, and how when we realize that, it changes the way we think about how we recommend content to people. And then finally, I'll end with some provocations to think about as we move toward the future of podcasts and audio recommendations. So the findings that I'm going to be discussing come from work that I did with Mozilla. It's important to note that this is from 2018, so the podcast world is evolving quite a bit, so keep that in mind. It's a blend of both qualitative and quantitative work. So from interviews that I conducted with 7 podcast enthusiasts who were recruited through a meetup group, so these were super into podcasting, and then also through some quantitative surveys that we deployed in a range of places, so through SurveyMonkey, through audio-focused subreddits, through the Firefox homepage, and through some social media channels. So I'll be kind of bouncing back and forth between those 2 different studies. Okay, so let's dive into the first theme about discovery, how people figure out what podcasts to listen to. So as a little bit of a thought experiment, I'd like you all to think about a podcast that you're just most into right now. I know it's hard to pick just one. And once you have that in mind, I'd like you to think about how did you find out about it? And if you feel comfortable doing so, go ahead and pop that into the chat in Zoom. I don't know, I don't think I have access to the Whova chat, but I should be able to see the Zoom chat. So if you're comfortable, I'm just kind of curious, like, did you find out about it from a friend, from an algorithmic recommendation? What are some of the things that you are doing? And I don't know, oh, I guess it's not actually showing me the chats, but hopefully you guys are sharing some of your thoughts there.
Johannes wrote from a friend.
Oh, I found the chat. Okay. Yep. So someone got from a friend, from a promotion, social feed of the podcast host. These are great. From YouTube, searching the topic. Yeah. So these are all ways of discovering content that definitely came up during the interview, and just so you can to kind of close our loop on sort of me and my podcast listening. So those ones that I told you about, this is where I found out about them, and you can see it's a range of ways, including recommendations from friends, promotion within another podcast, algorithmic recommendations, all kinds of places. So it's not like there's just one place that people are figuring out about what they want to listen to. It's a real mix. However, with that in mind, based on the qualitative interviews that I did, there was one way of finding out about podcasts that was just super salient and dominated all of the others, and that was word of mouth. And I say that it was salient because this is the thing that people brought up first. So I would ask them kind of open-ended, like, how do you find out about podcasts? And like, this was something that they all brought up unprompted without me having to ask, like, oh, do you use word of mouth? Like, this was something that everyone offered up. And that can happen through meetup groups. So keep in mind, this was sort of an atypical group that was recruited through a meetup. But they also mentioned a lot cross-promotion as well, and many other ideas, right? So the ones we've been discussing, algorithmic recommendations, web searches, articles. I thought it was interesting. Some people would sort of follow a celebrity or someone they really admired from a book or from a TV show over into a podcast. So they were sort of migrating from another medium. There was some use of social media, but not a lot. And just so you can see, here's kind of how it broke down in terms of what people brought up. And this is a small sample, so this is mostly just anecdotal. So what's really important here is kind of the way people talked about this and the values that we can find out from how they talked about these insights. I would love to redo this as like a large scale study, but I don't have that data yet. So if someone wants to do that, like, hit me up and we can, we can collaborate on that. So, but here are some of the things that they talked about when they mentioned how word of mouth operates. So it could be digital, it could be in person, and it definitely could be both on the show level or on a specific episode level. So here are some examples that I really like. So one person said, oh, I posted to my LinkedIn group and she thought, I've got to be the last person to have known about this. Like, everyone's got to know about it. But then over 100 people were like, oh, thank you, I'd never heard of that. Another example I love is someone said like, oh, I got a scam call. I put the scam call on speaker so that my coworkers could hear. And then after that, I said, hey, there's actually a specific episode of Reply All about this. So this way, it's kind of, these recommendations are operating as this kind of currency within these social interactions. So they're kind of a shorthand for things, and it's also a way to kind of gain some social currency. In terms of podcast cross-promotion, I actually think of this as sort of a subset of word of mouth. It's just coming from the mouth of someone on a podcast. So here are some quotes that sort of reflect that value. And people do form these deep relationships with podcast hosts. So it really is like getting a recommendation from a friend. So one person mentioned that like it's the most effective way when you hear about it on another podcast, especially when you get to hear a little sample, because then it's not just a recommendation, it's like real and concrete. And I love this language about it, whets my appetite and I can't resist. Another person said, I trust This American Life as much as I trust some friends in terms of taste and journalistic standards. So it really is more akin to a recommendation from a friend in some cases. So there are some other trends we noticed about how people work new content into their listening routines. I found it really interesting that this is something that people talked about as being requiring a lot of mental effort. It's actually hard to form a new relationship with a new show. And so this is something that people talked about as being sort of a little overwhelming. You know, there's friction in diving into new content. So you have to really, you have to really have a good reason to do it. We also noticed that these recommendations could be sort of cumulative. So if you hear about it enough times from enough different sources, then it sort of reaches this tipping point, right? So one person said, I might hear it from an anonymous source first, kind of like from radio, but then I'll hear it from a friend. And then I'm like, okay, that's the point when I'm like, I need to go check this out. So there's this sort of accumulation of sources. Also, people talked about how they have different needs and they want different recommendations based on their mood or even the broader stage of their life. So, right, we had one person saying like, most of the time I don't want true crime, but like sometimes I do. And like, that's when I need to see the recommendation for it. Another person talked about more like life phases. Like they go through relationships where like they have a relationship with a podcast and then they break up with it and they form a new relationship. Saying that my podcast listening goes in waves. That really reminded me of the movie Adaptation, if you've seen that, where Chris Cooper's character is like, one day I was just done with fish. And then he moved on to orchids. So these things kind of go in both short and long-term cycles. Okay, there were also some interesting insights, not necessarily directly related to how people find content, but to their listening behaviors that I think can inform how we think about recommendations. So one was that this notion of subscribing or following a podcast didn't completely capture the way people actually listen. So I asked them, how many podcasts do you subscribe to? And it ranged between about 10 to a shocking 72. And it wasn't like the person that had subscribed to 72 podcasts was listening to those all the time. Most people had sort of a smaller subset of those subscriptions that was like their core that they go listen to. And subscriptions could be something aspirational, kind of a log for later. Like, these are the things that I want to listen to someday when I get to them, or when I'm in the right mood, or when I'm in the right life stage. There was also one person who just eschewed subscriptions completely. So I thought this was interesting because we tend to think about people as forming relationships with shows, but she was really more topic oriented. She's like, you know what? I don't care about the show or the host. I care about the topic. So what I do is I search for audio content on a topic that I'm interested in, and I move from episode to episode. So I thought that was really interesting. The subscription model doesn't work at all for her in terms of how she thinks about content. All right, so let's shift into some of these listening behaviors and what we found out from the survey. So you might be wondering, how representative are these enthusiasts of a broader population? And if you're thinking, they probably don't represent most listeners, you are right. So our survey allows us to look across kind of the listening spectrum. So when we first put the survey out, simple question is, how often do you listen to podcasts? And we got this result, which was kind of shocking. We found that in our initial survey results, 40% of people listen daily. And if you follow any of the podcast statistics coming out from Pew or other sources like that, you're probably also shocked by this. It's quite high. And so we're like, what's going on here? Is our survey just like completely wrong? So then we actually went back and we segmented it by those different groups where we distributed the survey. Phew, okay, we found out that SurveyMonkey was much more representative of the sort of the typical American podcast listener. So if you look at the gray bars in the chart on the right, that's the SurveyMonkey panel. And you can see there's a lot more people that don't really listen to podcasts. The people that listen to daily, it's more somewhere around 12%, which is more what you'd expect. Whereas the blue, those are the people that found the survey through our audio focused subreddit. So these are the people that are the enthusiasts. So we can see there, in terms of frequency, these are two pretty distinct groups. And interestingly, there's kind of this bimodal shape. So you have a lot of people that listen a lot, and then you have a lot of people that never listen. And that middle area, the people that kind of, I listen sometimes, but not a lot, that's actually quite uncommon. So we found that really interesting, and that sort of guided the way that we analyzed the rest of our survey data. So let's take a look at some of the things that led us to. So we looked at sort of what devices people are using, and again, segmenting it by how frequently people listen. So people who listen on smartphones, that's something that they tend to do for daily listening, for frequent listening. Whereas if you're listening on a computer, your desktop or your laptop, that's probably more something you do for infrequent listening, right? Perhaps someone sends you a link and you listen in your web browser, something like that. If we dive even deeper into the apps people use, we find that there's quite different app usage between daily listeners and sort of mid-range listeners, and then there's very infrequent listeners. So with daily listeners, Apple Podcasts was the most popular, but they also used a wide range of apps, and there's a lot more people who are using multiple apps, right? They're actually using 2 or 3 or even more apps depending on their specific listening circumstances. Interestingly, YouTube was our second most popular app that people used, and I'll come back to that so in a few minutes, so remember that. And YouTube was much more proportionally popular among people who only listened infrequently. So YouTube was definitely this kind of like gateway app for listening. Okay, what about the people that don't listen at all? We care about them too. So in our survey, we did ask those people, why don't you listen? It wasn't because they hadn't heard of podcasts or didn't know what they were. Almost all of the non-listeners had heard of podcasts. And in fact, 57% said that they planned on listening and they were going to listen in the future, but for whatever reason, they weren't listening right now. So we asked a question about why people don't listen to podcasts, and far and away, the most popular response was that I just prefer to listen to other things instead. And I think this is really interesting because it's not that listening isn't an activity that they don't like, it's that the amount of time they have to devote to listening might be kind of finite. And so their listening is taken up with other things, right? Whether that's music or listening to video, as I'll get to in a second. Or they just haven't built it into their routines. Okay, so coming back to that question about listening to video, what is going on here with people listening on YouTube? So as I mentioned in our first survey, just asking what apps do you listen on, YouTube was the second most popular app. So we then did a second survey that looked at how all kinds of different audio content, so not just podcasts, but also videos, audiobooks, streaming radio, screen readers, all these other kind of things, how they interact with each other. So asking about all of those different listening activities. So we asked, of all these activities, what do you do at least once a month? I don't think it's that surprising that streaming music was the most popular. So 70% of people listen to streaming music at least once a month. What I was surprised by was that 60% of people said they listen to streaming video once a month. And that's, we explicitly said listen, and the whole survey was framed around listening and audio. So we don't think this was just people being confused by listening and watching. There were also 40% of people who listened to TV in the background. So what's going on here? Why might they do this? This is something that people do rather frequently. So this chart is a little bit complicated, and I apologize for the tiny axes. And I don't have a lot of time to go into it. But basically, activities on the left are things that people do rarely. Activities on the right are things that people do daily. And this activity of listening to videos or listening to TV was actually a high frequency activity. So people aren't just like doing this once or twice. Like the people that do that, they tend to do it quite a bit. We did have an open-ended question on the survey that asked why you choose to use the platform that you do. And so we got some insight into why people might be using a video platform like YouTube to do explicit listening. One reason was that there's just some content that you can get there, so people are going to follow the content. They're also listening to things that aren't necessarily podcasts, things like lectures, debates, vintage radio dramas that people have uploaded to YouTube. So things that aren't necessarily considered podcasts, even though they could be, and they could be distributed in that way. People also enjoyed using a video platform like YouTube because it allowed them to multitask, right? So one person mentioned that they have a tab open in their web browser at work. It's the video tab. They don't look at it. They're just listening to it while they're doing work. Another person talked about how their dream scenario would be I start watching a video, I leave, I walk somewhere, it's on my phone, now I'm listening, and then when I get back somewhere with a screen, then I can watch again. So there's this idea of like, how much attention do you have to devote? And using listening at times when you don't have your eyeballs. Also, some people just enjoyed things like the social features. They said, I'm listening to content, I wanna be able to comment on it and to discuss it with other people who are listening to it, even though it's not necessarily a video. Okay, so those are all the findings. I'm going to shift into the provocations, sort of the challenges and ideas that I want to leave you with. So in this vein of listening and recommendation, as someone who studies voice platforms, I think a lot about how an audio only or a voice only recommendation is fundamentally different than one that includes a screen. And so I want to think about how we might think about recommendations differently when we're in voice only or audio only platforms. To give you an example of why this is important, I turn to news on voice platforms because as a former journalist and someone who has studied news and how people consume it on technology devices, this is very important to me. There isn't a lot of research about how people consume news on voice devices, but one really useful white paper comes from Nick Newman at the Reuters Institute. And he raises this dichotomy that on one hand, people like voice and audio only platforms because it allows them to focus. So unlike having a screen where your attention can be grabbed and distracted and you can get sent down a rabbit hole, on a voice device, you have a focused piece of information that is provided to you when it's summoned. And that's something that people want. On the other hand, if you get only one response to a question that you ask with your voice, that's a form of narrowing. That's sort of a form of gatekeeping. And he refers to this as a choke point. So unlike a recommendation you can see on a screen where you can see, okay, here's your list of recommendations. If you ask, play me a podcast, you only get one result. You don't necessarily get to hear all of the other possible recommendations. And this is especially dangerous when we think about news. This work was back in 2018, but we are seeing this trend play out. I want to call your attention to a piece of research that was released just this week about Google News queries. So the authors here looked at 12 million Google News queries on both national and local news issues. And they looked at whether the results of those queries were coming from national or local news sources. And they found that national outlets dominated the search results. And this was true to a lesser extent if you were asking about local issues, right? So if you ask, what's the latest in my city council election, right? You were more likely to get a local news source, but you were still very often fed national news source results. And the authors point out that this could lead to a concerning feedback loop where attention is diverted away from local news. And although this study was done on Google News generally, that's the engine that drives how people access news on Google Assistant, their voice platform. And I think that this issue is even more critical on voice, where you don't get to see the search results. You only get to hear one answer, and that answer is privileged. So I challenge you to think about how we might have to treat recommendations differently for podcast and audio content on these type of voice-first platforms, so that we're not inadvertently perpetuating some of these potentially dangerous feedback loops. Okay, I know that was a little bit dark, and I don't want to leave you in a dark place, so I'm going to switch to sort of a more optimistic provocation. So I'm also very excited and optimistic about how, using some of the concepts from recommender systems, we might be able to tailor not only the content itself, but also the form of the content. So let me explain what I mean by that. So one example is length, right? So this is something that came up during the game, right? Do you like to listen to long or short podcasts, and where do you listen? And some of the big, 400-pound gorillas in the room are already dealing with this issue. For example, NPR, you can listen to their multi-hour daily news magazine, Morning Edition, if you have 2 to 3 hours to spend, or they now provide Up First, which is a lot of the similar content, just much condensed and only lasts about 15 minutes. Right, so if we know these things about people's preferences, about how much time they have, what context they're listening in, we can start to tailor things like the length of the content. I'll give you another example that's a little bit crazier, a little bit more out there, and this is from my field of sonification, which again is a graph for your ears. So if we know which ways people can comprehend things like audio data, we can then give them the version of that that's more comprehensible. And I know that was a little bit crazy, so I'll play you 2 examples. So these are 2 sonifications I made of the same data set. These are new coronavirus cases in Denver, the city near where I live, from March through June. And so it's the exact same data. Both of them represent more cases with higher notes and fewer cases with sort of lower tones, lower frequencies. But they're just done in 2 different ways. So I'm going to play the 2 clips. Give me a thumbs up that you can hear them. So here's clip 1. Okay, and here is clip 2. So again, that was the same data presented in 2 different ways. I have my own preference for which one I think is easier to comprehend and understand, but you might have a different preference. And so using concepts from recommender systems, we might be able to tailor content like this that goes beyond just things like length, but also the actual form of the audio itself. So that's kind of my crazy idea that I would like to see happening in the future. Really, basically, how can we make sure that podcast and audio content is personally relevant and also contextually relevant to people by not just recommending the content itself, but also the form of the content. All right, that's about my time. So before I get to questions, I do have a some quick thank yous. So if you want to read more about the findings from our podcast listener behavior work, I put the links up there for 2 blog posts that we wrote about it. I have to give a huge thank you to my collaborators, Janice Tsai, Abe Wallen, and Joe Fish-Kay, who were formerly at Mozilla, but who are now, I believe, all in the job market. So if you're looking to work with someone who has great expertise about podcasts, those are some excellent folks. Also, a big thank you to my advisor, Brian Keegan. And with that, I really look forward to answering your questions and having a discussion about some of these ideas.
Thanks so much. That was amazing. So if anyone has any questions, we can take some questions in the Whova chat. I think some people are probably joining from Whova. So we can relay the questions from Whova to you.
Cool. I can see the Zoom chat, but not the Whova chat. So that would be great.
Let's see. And if you're on Whova, you should be asking in the keynote session itself. Or if you're in the room, feel free to speak up. Because I don't see any questions in the chat right now.
I would be, hi, Jordan, this is Johannes. Thanks for the amazing talk. I would like to know how you recommend in a voice-only environment different podcasts. What kind of things did you come up there? Do you do like little introductions, or what kind of methods did you find there?
Yeah, so this is very speculative. Like, this is more kind of things that I would like to hear happening. So I think your suggestion about hearing little introductions is a really interesting one, right? So you could think about the way it works right now is you say, I'm not going to say their names because I have devices here and they'll wake up if I do, but you say, oh, play me a podcast, and it'll just start playing. But instead it could be like, okay, here are a few, I've got 3 recommendations that you might like. I've got a news podcast from NPR. I've got the latest episode of, a history podcast that I know you love, or I've got a super short, experimental audio podcast, and it could do little clips, right? So it could show you a menu. That might be a nice way to do it. So that's one idea I have. I'm really curious if you all have other ideas, and I believe probably some folks at Spotify might have looked into this. So I don't know if you want to jump in with anything that you've tried, because I feel like this is an issue with music as well. So yeah, feel free to jump in if you have other suggestions. But that's the first idea that comes to mind. And I agree that not just presenting, the text-to-speech voice saying, these are the 3 options. Like, if you actually get to hear a snippet of the audio that you're going to be listening to, that's a lot more potent than just hearing the text-to-speech suggestions.
Yeah, then I have a follow-up question concerning taking audio more into account. Did you analyze in your research also like the production or audio quality for itself of the podcast? Because, I mean, for me personally, when I hear something really nicely produced with original tones, then it's so much more interesting for me to listen to this podcast than some chatting?
Yeah, that's not something that I've explicitly looked at. I think that's a fantastic research question, because anecdotally I can say I'm like you, like the audio quality matters a lot to me. And from my days in radio, we used to have this phrase that when you had bad audio quality, like a phone tape of an interview that's all scratchy, we'd call that a truth killer, because it just, you don't trust it as much when the audio quality is worse. And this isn't something that I've ever seen someone confirm through a study. Like, I think that would be a great project to do. My best guess is that probably it matters more to certain people than it does to others. I think my hypothesis would be that it matters to everyone, but there's probably some people for whom that's that's just like a deal breaker. If it has bad audio, I'm one of those people. If bad audio quality is bad, I'm like, nope, I don't care how interesting it is. Whereas probably there's other people that are like, I will put up with that because the content is good. So I think that would be a great question to pursue further.
Great. And maybe if we have time for one more question from the room.
I have one. Hey, Jordan. My name is Anish. What is the most unexpected thing you discovered while you were talking to folks about podcasts?
So my favorite finding from the interviews that did not make it into this presentation or into the blog posts was that there were actually some people who did co-listening practices, which is like they would call up a friend and be like, okay, 3, 2, 1, go, start the podcast, and we're going to listen together. And this is something that we're actually now seeing a lot during the pandemic era, where people are at home and co-watching is sort of on the rise, right? These things like Netflix Party. And so that was something that I think was at the time probably a pretty rare behavior, right? So this was something where like, okay, this person's pretty extreme. He has a friend who's also pretty extreme, like they do this together. Whereas now, that's probably something that people want. So I was actually really intrigued by this idea of co-listening and how can we support people to listen socially, but it's not something that I had the opportunity to follow up at the time. So that's my idea. If someone wants to go out and explore co-listening behaviors, I think that is really fascinating and surprising. We were also super surprised by this YouTube thing, even though we maybe shouldn't have been, because it turns out so many people, but that was an example of how, as a researcher, like, if you're in your bubble of like, oh, all my friends listen to podcasts on podcast apps, you don't realize that there's these other behaviors happening, and that's why you have to go out and do this kinds of research. So thank you for your question.
Well, thanks so much, Jordan. That was a really fascinating and great presentation. And thanks everyone for participating. We are going to move on to the next paper presentation that is from Anish, who actually just segued himself in. So I'm going to, he's recorded his presentation, so I'm going to play it for you.
Anish, are you speaking? I think you're muted.
Sorry, Rosie, what?
Oh, I don't hear the audio.
You don't hear the audio. It's a little bit soft. Does anybody hear the audio? No, okay, let me start over. Thanks. Uh-huh.
Hey everyone, my name is Anish and I work at the Media Technology Lab at Gracenote. And today my co-author Amanmeet and I are talking about our work on podcast audio summarization. So to set the stage, podcasts have seen rapid growth in the last few years. Unlike music, podcasts require active attention and longer time investments from a listener. Content discovery is difficult. Listeners often rely on unreliable metadata like the text description to discover new content. Subjective factors are significant influencers of user preference, including things like the presentation style of the speaker, their production quality, and the type of humor. Some of these are hard to quantify or infeasible to extract from the audio or the text metadata. We propose an audio summary that can help a listener preview an episode, understand what it's about, and make a judgment about whether to listen to the entire episode or not. In this way, an audio summary is performing a function similar to that of a movie trailer, but is created automatically, necessitated by the scale of podcasts. So, to reiterate, our goal is to create an audio summary for the podcast in an automated manner. Our key idea is that we can pose the audio summarization problem as an extractive text summarization from the transcript. So we first transcribe the speech from audio, we perform text summarization from the transcript, and then synthesize an audio summary. This task is challenging for many reasons. Podcasts often have overlapping speech and music, or multiple speakers talking at the same time. Podcasts often contain spontaneous speech, which could have repetitions, disfluencies, grammatical errors, and such, unlike written text. Podcasts may also contain advertisements and announcements in addition to the main content. There is a lack of research datasets for podcasts in general. Hat tip to the folks at Spotify for starting to change that. However, there are no datasets for this particular task of audio summarization for podcasts, so we had to go about creating one. We also find that existing state-of-the-art approaches for text summarization don't work too well out of the box for podcasts, and we'll see some results towards the end of the presentation. Here is an illustration of our podcast summarization, or PodSum method. We first use automatic speech recognition, or ASR, to get a transcript from the audio. We then process that transcript to split it up into sentences, or sentence segmentation. We also keep track of the offsets of the sentences in the audio file. We then use a text summarization module to select sentences that would constitute a good text summary. And finally, we use the offsets of the sentences to get the segments of the audio. We stitch up these chunks together to form an audio summary. So our input is podcast audio, we perform our processing in the text domain, and the output is an audio summary. Our method leverages a lot of existing work. We use an off-the-shelf ASR offering from Amazon, which is the AWS Transcribe. It outputs a transcript with word-level offsets and punctuation, which makes the downstream tasks easier. We use Spacey, a popular library for NLP in Python, for the sentence segmentation. Additionally, we force a sentence break for long pauses over 2 seconds. This was required to fix some edge cases from the ASR method. For the text summarization, we use Presum, a model for extractive text summarization based on BERT. We fine-tune this to our own dataset. And finally, the audio generation step simply combines the audio segments for the sentences predicted by the text summarization. So Presum is a BERT-based model for text summarization. We use the extractive summary variant. We don't have time today to dive too deep into details about the model, so please refer to the citation below for more information on Presum. But in brief, it's convenient to think about the model as a classifier. It assigns a score to every input sentence, to represent the likelihood of its inclusion in the summary. We start off with a model pre-trained on the CNN Daily Mail news dataset and fine-tune it with our own internal dataset for podcasts. In here, I hand off to my co-author to walk through the details about the dataset and talk about our results.
Hi, so far we saw why the podcast summarization problem is important and how the PodSum method aims to solve that. Now we will look at the custom dataset, the training protocol, and some results. In our dataset, we had to design a custom protocol where the individual rater would listen to the audio podcast to gain the context and core message, and subsequently select a set of sentences which represent the summary of the podcast, ideally selecting a set of continuous sentences up to 120 seconds collective length. All in all, the dataset contains 309 episodes to giving us 190 hours of content, anywhere between 15 to 22 sentences per summary, taking 4 to 9 minutes per episode per individual rater. What you see in front of you here is the labeling system that was given to the individual raters. We have the metadata that is displayed here, the transcript along with the corresponding time offsets provided from the transcription system, and here there is a selected summary auto-generated for the reviewer to listen to. So the rater would listen to the podcast. They would go and select individual sentences highlighted in the green. The system automatically stitches them together to provide a selected summary, which the rater can review, and then once satisfied, they can submit for further use. In our work, because our data we find that includes repetitive content, we provide a data augmentation method whereby we use these repetitive contents to randomly replace them such that the system learns a better representation of the underlying summary. So what you see here is in the red is a piece that was found to be repetitive across the series of episodes within our data set. So very briefly, we find the repeated sections such as RC1, RC2 as depicted here, and we randomly replace them with similar repetitive content from other episodes using different ones in different places as well. So all in all, we generate about 20 augmented samples per podcast episode. For our model training, we identify that we have a small data set with us. So in order to get an unbiased performance measurement, we perform a cross-validation experiment with 5-fold cross-validation. For the model fine-tuning, we start with a pre-trained model with pre-training on the CNN Daily Mail dataset for summarization. We continue the training for 6,000 steps with a batch size of 3,000 and truncated up to 512 tokens as input to the model. For the metric, we report the values of the Rouge L, Rouge 1, and Rouge 2 score, highlighting the overlap between the prediction and the ground truth, whereby Rouge 1 and 2 highlighting the unigram and the bigram, and the Rouge L score looking at the longest common subsequence that was common between the prediction and the ground truth. So we expect to receive high values of overlap, thus values closer to 1. In our results, we performed a lot of analysis. For a baseline, we compute the lead scores where we look at, randomly without any algorithm and learning, selecting the first n sentences, n being 5, 9, 12, 15 in our experiment. And we find that when we just select the first 15 sentences, we get the highest performing F score for the Rouge 1, 2, and L, suggesting that, longer sentences are utilized inside the summary, whereas the early sentences do not form that strong a component towards the summary. Similarly, fine-tuning with our custom data set on the pre-trained model, we see that when we have no fine-tuning, our system performs suboptimally. When we fine-tune with our data set, without any augmentation, we get some improvement. But when we include augmentation, the system shows an improved performance, suggesting that augmentation helped the system to become more robust. Likewise, in our ablation experiment, we find that selecting different number of sentences and picking the best candidates from there, we find that around 12 sentences we get the peak performance, whereas going longer, our overall performance reduces in the root scores, suggesting that around 12 sentences is where the summary data set suggests the best summary exists. What you see in front of here is the distribution of selected sentence indexes. In the blue is the ground truth, and then the orange, the green, and the red are the predictions. The red being the best performing system. As you can see, the trend is shift towards the right side, towards the higher sentence index, suggesting the model trying to learn closer to ground truth distribution in the data. So now we will look at a brief example where what you see is, one of the transcripts of a model, and in different colors are the performing outputs, whereby red is all the false negatives which were missed by the model. The blue is all the false positives which were not there in the ground truth. The magenta is where we found the repetitive content, and all the greens are the correct predictions. So what you see, we have a lot of variety of colors, therefore suggesting that the fine-tuning, without the fine-tuning, there is an inferior performance. But with fine-tuning, we see that now the green has increased, suggesting that our model is able to learn better and predicts more closely to the ground truth. So as an example, we will play the sequence here to see what the fine-tuned output looks like.
You talking about the 2020 race and more. To get your tickets, head over to nprpresents.org. Oh, and if you're in Iowa, we have a show there tomorrow night, Friday night, and there are still a few tickets available.
The Senate will convene as a court of impeachment.
Today, the Senate impeachment trial is continuing with more questions and answers, senators asking questions, the House managers and the president's legal team answering those questions.
What we saw was a very small example of how the summarization system is able to pick selected pieces which represent a best summary as per the underlying data from where it is learning from. So this suggests that our system has a lot of promise. Obviously, there is a lot of work to do, which leads us to some limitations that we identify where we have a small data set, potential bias towards the genre as our variety of episodes was limited, and we only were able to get one rater to give us ground truth labels per episode, therefore potential rater bias and very limited audio processing for our current work, which leads us potentially to do more work, looking at a larger data corpus, higher number of raters, looking into audio processing for speaker diarization, etc., and summarizing longer podcasts. And with that, we thank everybody for their time and happy to take questions.
Excellent. Thanks so much. Let's take a couple of quick questions here from the room. I don't know if people are on Whova anymore. Anyone have a question for Anish?
Can I ask a question?
Yes, please. Go ahead.
Hey, Anish, thank you so much for your interesting work. I learned a lot from your paper. I just have several questions because here you're doing extractive summarization. Basically, you're selecting the sentence from the transcript. In your example, you color the correct prediction as the text, the green text, right? So how do you identify which should be the correct prediction?
So in our data set, we have people annotate our transcript, right? So if you remember the slide, there was an interface where people selected them. And any overlap between those sentences and the sentences that the model predicted is considered a true positive. So those are shown in green.
I found that evaluation method very interesting and thorough. The obvious baseline evaluation would be to compare against the creator description. Did you do that evaluation?
That is a good question. So we thought about it. We looked at a few descriptions, and then we found there was, I think some of the previous talks mentioned, there's not too much a correlation sometimes between the two. We did consider trying to use the abstractive summary to sort of inform an extractive summary, but I think our data set was a little small to try and find these sort of patterns. So we looked at named entities and such that occur in both the provided summary as well as the transcript.
I think it would be an interesting extra experiment just to calculate the Rouge score with a creator description, even though it's not just to sort of show what difference you get when you do that manual annotation. I think that would be an interesting extra contribution.
Yeah, that's a great suggestion. Thanks.
Excellent. And maybe let's do one last question. Or we can move on. So thanks to Anish again for the great presentation. And next up we have Greg Benton. He'll be presenting trajectory-based podcast recommendations. And Greg, you can take the screen.
All right. Just get everything organized. Can everyone hear me and see the screen and everything?
I can.
Okay, I'm seeing some thumbs up. Great. So hi, I'm Greg, and this is our paper trajectory-based podcast recommendation. This is work I did while an intern at Spotify with the tech research group. So it's work with Ghazal and Alice and Ben, so a lot of credit to them. Yeah, so I'll just dive right in. So kind of where are we with podcasts, right? Well, the library of podcasts is massive and growing. So recommendation and discovery are key to driving podcast consumption. How can we get to a place where we can really help people find the content that they want to listen to? Right now, a lot of the standards are driven by collaborative filtering approaches. And while these can be good, they have shown to be a little bit limited in personalization and discovery in our experiments. So we really wanted to think about how can we extend this and kind of help people search the space of podcasts that's just becoming so vast and continuing to expand. So let's suppose that this is a graph of podcasts, and these edges can be anything that you want. They could be these shows talk about a similar topic, or they're published by the same producer, they have the same host. We'll just leave that kind of vague for now, but suppose this is a graph. One way that we could make recommendations is we could just think about the show that a user currently listens to or has listened to last and think about where they might want to go from there. Alternatively, we could just take the last few shows or however many shows these are listened to and treat these as kind of an unordered bag of shows and make a recommendation from that. And what we're going to do here is think about a sequence of shows. So now we have some ordered structure to the way the user is navigating this space of podcasts. And we want to think about the trajectory that they're taking and make recommendations based on that. So this immediately gives us a lot more structure that we can use to make recommendations. Like if we see this kind of trend emerging where this user's moving left to right in kind of this toy example, we don't necessarily expect them to U-turn. We might want to make a recommendation that pushes them forward in this trajectory. So with that as kind of the motivation, I'll give a high-level model overview, and then I'll kind of move into some of the results and insights that we gained. So the first thing we have to do is handle the shows, so this library of podcasts. And what we do is we embed these shows into a vector space using a distal embedding of the knowledge graph. So the knowledge graph just connects shows based on who they're published by, who they're hosted by, what topics they cover. There's kind of a lot of connections there. So it gives a really good high-level semantic overview of what the podcasts cover. So we can actually just, this is a real visualization of this knowledge graph where we've just embedded it into, or projected it down into a lower dimensional space. And you can see that these three shows that are quite similar, they all cover kind of news and current events and politics, get put into the same cluster. So this just gives us more information than kind of what users are listening to shows. It gives us a bit more insight into what's actually relating shows. So with those embeddings, we can kind of zoom in and we get this just a little fake chunk that we'll look at for an example. And then we have to think about how are we going to transform sequences that have been listened to by a user into something that we can kind of then use to make recommendations. So what we'll do here is we just consider the first time that a user listens to a show as kind of their connection to that show. And as long as they listen to it for at least 30 seconds, we'll count that as them having heard that show. So that just kind of filters out accidental clicks or someone that kind of started something but immediately changed their mind. So then we have these sequences that are embedded into a vector space. And then we want to use this idea of trajectories to make recommendations. And all we're going to do for that is just pass this into a kind of simple recurrent neural network. And this just gives us the inductive bias that the data are sequentially dependent. So 2 is dependent on 1 and 3 is dependent on 2 and 1. And then whatever we recommend for 4 will be dependent on 1, 2, and 3 in order. So the framework for that just kind of looks like this. We feed in a bunch of shows, and then we pass through kind of a couple dense layers. And then at the end, we're just going to generate a probability distribution over the potential candidates for recommendation. And then we can recommend shows in order of decreasing probability that that would be the next show in the sequence. So high level, we embed into a vector space, we take a sequence by a user, and then we just pass that into this sequential model. And that gives us probabilities of the next show in the sequence. So I'll go over some of the results and insights, and we're gonna kind of have to go through some of the numbers, these kind of quantitative results. But I also do want to highlight that some of what we got from this was not just kind of this methodological insight, but some insight into how podcasts are consumed and what we saw through the development of this model and kind of through analyzing what the successes were. So the two metrics we'll look at are success at 20, which is just what % of the time can we capture a recommendation, or what % of the time can we capture a user's true next show in the top 20 recommendations, right? So we take a sequence of shows and we'll hold out the last one that a user listened to, and then we'll try to recommend that to them. And then if that's in the top 20, that would count as a success here. And just what % of the time can we do that? And the next metric is just mean reciprocal rank. So kind of the same thing. We want to take this held out last show and try to rank that as high as possible. So kind of the details of these aren't super important. It's just two metrics that we can use to think about. If we were to give someone kind of 20 recommendations, would we give them what they wanted? And how far off from, as best as we can do are we doing? So we want to maximize both of these. Higher is going to be better kind of for the rest of this. So I kind of started off and I said, collaborative filtering isn't working super well, and no one unmuted themselves and told me I was wrong, but I just circle back to that really quickly. We can kind of compare just to baseline non-negative matrix factorization based collaborative filtering, and immediately without much tuning in our model, without kind of really thinking about these design choices and how we're subsetting on data, we're doing 6 to 7 times better in terms of mean reciprocal rank, and almost 4 times better in terms of success at 20. So I'm not going to keep coming back to collaborative filtering, but this is just to indicate that right off the bat, we're making a lot of gains. So let's see how far we can take this if we kind of make better choices about how we source data and how we structure this model. One thing that jumped out really quickly is that data curation is important. And this just kind of goes along with how podcasts are structured, and then some demographic information as well. So consumption is very distinct by age. So all the way on the left, we have just the age distribution over our data set. And then we can pick out 2 example shows and look at the age distribution of users that listen to those. And what this shows is that if we split things up based on age, we can actually have a much higher success rate at recommending shows to users. So all we do is just train a few different models, one for each bracket of ages. So below 20, 20 to 29, 30 to 39, so on. And I'll show that on the next slide. And then the other thing that we found was that consumption is very distinct by topic. So we have these kind of high level topics that are assigned to each show. Each show can have as many topics as it needs. And these are really broad. So things like news or daily news, politics, sports, it's not super fine grained. And we find that the sequences that users listen to are actually they don't really cross topics very much. And this makes a little bit of intuitive sense, right? That the comedy shows that someone listens to at night might not really inform the news shows that they were listening to on public transport when they used to go to work 6 months ago. Those are probably different patterns in listening, and they might not inform one another. So we will split up users' sequences based on topic, and then we'll make them recommendations within that topic. And then the other really big insight that we got was that user trends are surprisingly local, and I mean that in 2 ways. So one is that they're very local in time. So if we source data over 1 week, we're going to have a much better time recommending shows for a user than if we source them over longer periods. So kind of the high level takeaway is that I've said high level so many times. One takeaway here is that what a user did 3 weeks ago won't really help us understand what they'll do next. So here we just compare what if we don't split on age and what if we do split on age, and what if we source data over 1, 2, 4, or 6 weeks. And we can plot this as well. And what you can see is that if we source data over shorter time periods, we do better. And if we split up on ages, we do better as well. And it's basically monotonic. As you source more data over longer time, you just lose some connection in the sequences, and you can make far less successful recommendations. And this pattern does hold if we split up on other age groups as well, but just for clarity, we're just going to focus in on ages 20 to 29. So the other way that user trends are local is in shows. And what I mean by that is that we have the sequence 1, 2, 3, ... n, and then we want to make a recommendation for the n+1 show. And we need to figure out how many shows are in that ... What does that ellipsis represent? And it turns out that the shorter we can make the sequence, the better we'll do. And this is maybe a surprising result, but I think there's a few ways that we can think about it. One is just that these sequences detach really quickly. Maybe a user listens to a ton of episodes of a show, and what they listened to 4 shows ago, now they've listened to maybe 100 podcast episodes, and those shows a few shows back are no longer really influential in what they're going to listen to next. So if we just think about what's the input length to this model, we can see that if we input these short sequences, it's almost twice as good at getting success at 20 as an input length of 5, right? So if we just put in 2 and try to recommend 3, we're going to do twice as well as if we input 5 and try to recommend 6. This is one of the kind of surprising results. So you might ask, well, why not just feed in 1 show? Well, then we lose kind of this whole inductive bias of sequential structure, but we'll try that. And this will just kind of close the loop on this idea. We started off and said, users consume shows sequentially. That's our inductive bias. We want to follow through on this. Let's go back and test that out. We can make a similarly structured model as close as we can, just losing that those recurrent cells in this deep model, and try to feed in a bag of shows and recommend the next one. And what you see is you immediately lose about 10% success at 20, and the more shows you feed in, the worse you do. And now maybe you're wondering, well, these aren't the same model, so we can't really do an apples to apples comparison here. One thing we can do from that is just shuffle everything. So we have these sequences of length 3, a ton for each user. We'll just shuffle them up, and we'll try to use that as our data, and we'll try to recommend this kind of permuted third show for each user. And again, you lose about 7 to 8% success at 20. So there is some inherent sequential nature to the way that users are consuming shows, and capturing that gives us an ability to get very high success at 20, very high mean reciprocal rank. You can see we're not really recommending a lot of shows that are, we're not assigning really low recommendations to a lot of shows. Like there's not a lot of recommendations that are out in the 1000s, 2000s, etc. Even when we miss, we're still kind of in this highest category of recommendations that we could make. So I thought this locality and this sequential nature was pretty interesting, and it really enabled us to do quite well. So I think with that, there's a couple key takeaways here. One is that we have a new podcast recommendation method that is sequentially structured and gives us a huge boost over baselines in terms of metrics like success and mean reciprocal rank. But potentially just as exciting is that we have this better understanding of user behavior. So user consumption of podcasts is structured over short windows of time and short show sequences. And it is sequential in nature. And then the last thing is just that we have this importance of subsetting on relevant variables. So these sequences don't really cross between topics, and they're consistent potentially within just subset age groups. And I think that's all I have. So thank you. This is a really fun project to work on, and you're doing some really cool stuff at Spotify. So happy to pitch that anytime.
Awesome, thanks. We have a question from Brian. Did you try any content-to-content nearest neighbor methods?
Did we try any content-to-content nearest neighbor methods? I'm not sure I fully understand.
I think
maybe it's badly explained, but I basically just mean there was some results in sequential recommendation that showed that nearest neighbor methods, where you just collaborative filter embed the content sort of independent of sequence initially, and then say, once I've listened to a podcast, you just look. So I don't know, when you said you did collaborative filtering, I didn't know, do you recommend the closest item to the user or the closest item to the previous podcast? That makes sense.
So yeah, that makes sense. So when we did collaborative filtering, that example was based on the nearest show to the user. But initially we had tried to see if we could just do things in terms of cosine similarity in this embedded space, which I think might be kind of what you're getting at. And it was not super successful. I don't want to say too much because I haven't seen the data in a little bit. But the failures in that were why we moved to this recurrent structure.
Cool. And anyway, when you showed the fact that the model that only takes the most recent track couldn't get to the same performance as the one that took the two, kind of also makes me think that sequences are really important. So.
Yeah, definitely.
That was pretty neat.
Thanks. I see another one here. Do you think looking at a sequence within sessions would improve results? I'm thinking people's behavior changes across sessions depending on time of day, context, etc. So I think that those are all really important questions. Some things that we discussed but just didn't get around to looking at were how things change throughout the day. So, you know, is morning versus evening an important variable that we might want to think about? I'm not sure about looking at sequences within sessions, just because the typical podcast is a bit long. So if we wanted to say, oh, well, what are the two or three shows that you listened to while you were on the platform, that might really just restrict how many people this could apply to, because there's probably not that many people who are sitting down and listening to 2 or 3 different shows without leaving the app. Can some of this short-term behavior be explained by listening to episodes from the same show? No, because we're just looking at the first time that a user listened to a show. So once they listen to the first episode of that show for at least 30 seconds, that counts as them having listened to that show, and then anything after that we just kind of ignore. So we can't have a record of them listening to the same show twice.
Hello.
Hey.
Actually, I have a question. So for the success at 20, why is it 20 exactly? Like what I usually see is success at 10. People change it, but I don't know, did you choose it based on the results, or it was just we decide it's 20?
Yeah, it was just totally arbitrary. I'm not trying to hide anything beneath.
Oh no, it's not because I've seen a lot of criticism lately, a lot of papers criticizing how people choose different setting. People, some people choose success at 400 and others at 10 and others at 200. So it's it was arbitrary.
Yeah, it was totally arbitrary. I think early on we were thinking about what success metrics we wanted to use, and someone in the meeting was like, "Oh, you could use, success at 20 or something." I was like, "All right, that's what we're using."
Okay.
What I do know is that the success is quite consistent. So it's not like they're all the recommendations are lumped between 10 and 20. And if you went down to 10, you would see this massive drop in performance.
Yeah.
Right. You would see kind of you would see the result that you would expect given things are consistent, right? If we look at, I know I can't go back here. If we look at one of these plots, that kind of sharp peak at high recommendations, and then it cuts off quite quickly. If you zoom that in, that trend is consistent. So if you went 0 to 10, you'd be fine.
Okay, thank you. Nice work.
Thank you.
Yep. Thanks a lot, Greg. This was a great presentation. Thanks for all the questions. Let's do one last question from Matthew.
Do you have data on the number of sessions that were a single podcast show versus multiple? No, I don't have that. And do you think for some users, discovery may be a conceptually separate interaction per user as opposed to listening? I can only give an answer to that based on intuition, just because I really only interacted with the Spotify platform for a few months. So I don't have a ton of data to back this up, but I think that probably makes sense. I think one thing that seemed to show is a lot of times people log on and they know what they're going to listen to, right? Like they get up in the morning and they're going to listen to the daily every morning, and they don't need discovery. So I think there is kind of this space between listening and discovery where some people know what they want to listen to and some people are looking for something new. I know there's a lot of exciting work going on regarding that specific question at Spotify. So hopefully that will come out soon.
Cool. So thanks again, Greg. Great presentation. And so we're almost at the end of our time. I'm going to wrap things up with a very few words. So this is all the things we saw today. It was really a pleasure to see and hear all the papers, the activity, and the keynote. I want to leave us with that slide that I put up there at the beginning about the research challenges. And after going through the program today, I feel like this still kind of stands. I think a lot of the things people talked about fall into some of these categories. I sort of think of the first one, the cold start, as more like the interaction patterns. And now that we have, podcasts being different, people interact with them differently at different times for different reasons. What does that mean for podcast recommender systems, and how do we need to change RecSys techniques to deal with the new paradigm of podcast listening? The second bucket is really kind of that question about like needing to know more about the podcast. And so that's going all the way down to the audio level, and also, from the text transcriptions, summarization, sentiments. And again, how are those tasks, we heard from some of the papers and the activity too, like how are those tasks different from like news summarization or different from, web search? I think there's a lot of interesting research to do in there. And then, Jordan very nicely kind of touched on this in her keynote around fairness and safety, like with podcasts being, when you talk about news podcasts or like informational podcasts, and especially as we talk about, voice interfaces like speakers where you only get one chance and there's this gatekeeper effect. I think the potential impact and potential harm of podcasts is something that I feel like, as someone who's worked in a music company for a long time, was getting into podcasts, like the level of care we need to take is like a whole different level here with podcasts. So there's a lot we can do there, and I hope to see all of these research questions kind of investigated over the next year, and hopefully we can have another one of these next year. So I wanted to thank everyone, all of you watching this. I especially wanted to thank my co-organizers. It's been an honor and pleasure to organize this for the last several months over pandemic and everything. And I hope that we can continue the discussion, keep this community going. I went ahead and created a Google group. It's called PodRecs. So if you go to that URL, you can ask to join, or maybe you can just join. I think ask to join. So I hope to see you all there. And yes, thanks again. And enjoy the rest of RecSys.
Thank you, Jingwei. Thank you to all the speakers. I really enjoyed everyone's participation. Thank you for everyone who joined in the recommendation game as well.
Thank you all.
Thanks all.
Thank you.
Thank you.